food here. Space and Rocket Review is ready to go. Here, watch this.
NASA's space shuttles are some of the most high-tech and complex vehicles ever built, but they couldn't fly without the help of a much older technology, the railroad. This is no ordinary train. It's the NASA Railroad at Kennedy Space Center in Florida. It carries extremely dangerous freight, one of national importance.
It's not something to just kind of sneeze about, you know. When we're hauling in, we're hauling 4 to 5 million pounds of explosives.
One shuttle solid rocket booster contains 4 motor segments packed with a hard, rubbery, volatile solid propellant. Every space shuttle launches with 2 boosters, which give the vehicle the extra thrust it needs during the first 2 minutes of the climb to orbit. The large, heavy motor segments have to take a week-long cross-country train ride from the ATK manufacturing plant in Utah to NASA's Kennedy Space Center in Florida.
In shuttle, of course, with the segments, it is absolutely essential because you're looking at an average of approximately 150 tons per segment, and with 8 of them per launch, there really isn't any other better way to get them here from Utah. It's just an essential lifeline is what it boils down to.
Today, this important but hazardous job is handled by URS Corporation engineers and mechanics in the railroad shop. The 11-member team takes care of all the rolling stock and the track system, including electrical work, mechanics, painting, welding, and even fabrication. That expertise is essential when it comes to handling the solid rocket booster segments, which travel to Kennedy on cradles inside custom-built rail cars. During the trip to Florida, the segments are handed off from rail company to rail company, with the final handoff at NASA's J.J. Railroad Yard north of Titusville, Florida. The Florida East Coast Railway, or FEC, delivers the segments to J.J., and that's when Kennedy's railroad team takes charge. After a thorough inspection, empty spacer cars are added to prepare the train for the trip across the Indian River to Kennedy.
The main purpose for us is to distribute the weight on our bridge coming across the Indian River. If you have all the heavy cars tied together, that puts a strain on the bridge, so try and separate the weight.
The Kennedy rails can handle speeds of up to 60 miles an hour, just like FEC's mainline track. But because of the heavy and volatile cargo, the top speed here is only 25 miles an hour, and the trains typically move slower than that. All the work is done by a 1,500 horsepower locomotive known as the EMD SW-1500. NASA has 3 of these workhorses. They were built by General Motors between 1968 and 1970 and put to work for the space agency when shuttle loads demanded a lot more horsepower.
They do have a lot of backbone. And again, when we bring in the segments and the spacer cars, you know, we got probably close to 4.5 to 5 million pounds that we pull with one motor.
Once the train arrives north of the Space Center, the spacer cars are removed and taken back to the rail yard. The booster cars are kept at suspect sighting, an isolated staging area near the shuttle runway, until they go to the rotation, processing, and surge facility to start final launch preparations. When the boosters are recovered after launch, the same team loads up the spent segments and sends them back to Utah.
Got a great track record, and it's basically a pretty simple process, you know, from all the way from Utah all the way to here to getting it on the launch pad, and the system has worked great.
Kennedy's rail system was activated in 1963 to bring in construction materials for the growing Space Center as new facilities were built for the Apollo program. But throughout the years, the Florida climate took its toll, and hauling shuttle segments presented unique challenges of their own.
Well, fast forward 20 years, and the space shuttle program was starting, and we were looking at freight cars that were somewhat longer and a lot heavier and had a high center of gravity as well.
FEC was paid to upgrade the aging system with heavier rail, welded joints, and concrete cross ties. Along with rolling stock standards like hopper cars and gondola cars, Kennedy also has some cars that were modified or even designed here. In fact, Hoffman himself designed the booster structures car.
It's a custom-built car. It's a concept I came up with to improve on the delivery of, or the movement of the solid rocket booster aft skirts, the forward skirts, and the frustums.
Many other commodities have traveled these rails, such as nitrogen tetroxide rocket propellant, Air Force Titan rockets, Navy Trident missiles, and the shuttle-derived booster segments for the Ares 1X test flight.
It's not just moving segments. We've done so much more. We've rebuilt the Air Force locomotives. We've built rail cars. We've done painting. I mean, this locomotive here, you can see how much better it looks than the other two and everything. So we're a pretty diverse group and we stay busy.
The result is a vital and successful rail line that has stood the test of time. In May 2010, the last load of shuttle solid rocket booster segments came to Kennedy.
For the most part, it's you know, it's kind of like any other railroad, so to speak. We don't run the speeds, but the things that we do and have to do when we're loading and unloading, you know, demands your attention, demands respect.
The NASA Railroad at Kennedy Space Center has played a quiet but critical role in the Space Shuttle program, and the hardworking team hopes to put its talents to use on future spaceflight endeavors. NASA's space shuttles are some of the most high-tech and
the moon, closest neighbor to Earth. Presently the focus of man's greatest scientific adventure, the first celestial body that will be explored by man. Landing men on the moon will be a truly great achievement, but only the beginning of a new era in space exploration. No one can predict the exact missions that will follow in the years and decades ahead. But the most exciting possibilities will require the acceleration and deceleration of very heavy loads, such as the maneuvering of large Earth-orbiting spacecraft. The transportation of large amounts of equipment and supplies to the lunar surface, and the sending of heavy spacecraft to the planets. Today's missions are being accomplished with rockets that burn chemical fuels. But chemical fuels are heavy, and the cost of putting each pound into Earth orbit is very high. Nuclear rockets, when perfected, can provide the same propulsion energy with less overall weight. They will expand our ability to explore space. This is the story. This is Saturn V, the most powerful launch vehicle being built by the United States. A three-stage rocket that will place the Apollo spacecraft in the vicinity of the moon. The total weight of Saturn V is about 6 million pounds. Its three stages have chemical engines that burn fuel to generate thrust. The first and second stages provide most of the energy needed to put the third stage and the payload, about 250,000 pounds, into Earth orbit. At present, only chemical rockets can provide the high thrust needed to do this job. The third stage accelerates the payload to the velocity needed to get it to its destination. Here, travel time and payload weight are determined by the efficiency with which the propellant is converted into thrust. By substituting a nuclear third stage for Saturn V, the velocity of a given payload can be greatly increased, cutting travel time for some missions in half. This is particularly important in sending deep space probes to Jupiter and beyond. Or if shortening travel time is not essential, propellant weight can be traded off for an increased payload weight. This is important for a lunar supply mission, Earth orbital operations, and some unmanned missions to the planets. Why is the nuclear rocket so much better than the chemical rocket? In rocket propulsion, exhaust velocity determines propulsion efficiency. At a given temperature, the lighter the exhaust gas, the higher the exhaust velocity. And the higher the exhaust velocity, the more thrust is generated for each pound of propellant consumed per second. The nuclear rocket merely heats hydrogen, the lightest element of all, and expels it at tremendous velocity. Chemical rockets burn fuel to produce exhaust gases that contain heavier elements. So at the same exhaust temperature, the exhaust velocity is much lower, and each pound consumed per second produces less thrust. Rocket efficiency is stated in seconds of specific impulse. This refers to the time in seconds that 1 pound of propellant will deliver 1 pound of thrust. The higher the seconds of specific impulse, the greater the propellant economy. Our best chemical rockets of today are limited to a specific impulse of about 450 seconds, and only slight improvement can be expected. On the other hand, full-scale nuclear reactor tests have achieved 800 seconds, and laboratory tests promise even more, perhaps as much as 900 seconds. This means the nuclear rocket, with its lightweight, high-velocity exhaust, will use propellant about twice as efficiently as chemical rockets. This, then, is the principal advantage of nuclear propulsion.
It was at the AEC's Los Alamos Scientific Laboratory, high in the mountains of New Mexico, that the first steps were taken. Here, in the mid-1950s, scientists set about to determine if nuclear energy really could be used to provide rocket propulsion. Theoretical studies and early experimental work revealed many problems that would have to be solved. Problems in reactor design, material, radiation, structures, control, to name but a few. The nuclear rocket was found to be feasible. A series of experimental reactors was planned to convert theory into workable hardware. Optimum reactor designs were worked out by analysis. Prototypes were built. a comprehensive test program was started. These reactors, called Kiwi, were to be used to prove out design and operational concepts. They would be built only for ground testing. All Kiwi power tests took place at the Nuclear Rocket Development Station at Jackass Flats, Nevada. Here in the desert, scientists and engineers checked the actual performance at various power levels and for various time periods. Each experimental Kiwi reactor was received in sections, assembled and checked out in a special reactor maintenance, assembly, and disassembly building called simply RMAD. When the reactor was ready for testing, it was placed nozzle up on a special rail car and delivered to the test stand a mile or so away. This car could be controlled from a remote station. Liquid hydrogen from nearby storage tanks was pumped through the reactor. First tests were begun in 1959 and were run to the 100 megawatt level, about 1/10 of Kiwi's ultimate goal of 1,000 megawatts. Later tests, beginning in 1962, operated at the full 1,000 megawatts. Films of these early tests show the flaming torch on the test stand that burns off the hydrogen exhaust gas and prevents an explosion hazard to the test facilities. Upon completion of these tests, each reactor, by then radioactive, was transported by remote control back to the RMAD building for disassembly and inspection. Here, men working behind shielded walls used remote-controlled manipulators to remove the components for careful checking and analysis. Each test firing added information that helped scientists evaluate the reactor's performance and enabled them to make adjustments and corrections before the next reactor was assembled. But not all tests showed perfect performance. In this one, for example, the flashing in the exhaust gas indicated a structural breakup caused by excessive vibration. Extensive redesign and testing were needed to correct the flaw. And in this test, a hydrogen leak caused a fire on the test stand. Again, a correction was made. Each test brought the scientists a little closer to the performance they were seeking, until finally, in September 1964, the 8th Kiwi reactor was brought up to full power and held for 8 minutes. And a few weeks later, it was restarted and operated at full power for 2.5 minutes. Specific impulse, about 750 seconds. This concluded the Kiwi test series. It had proved that a nuclear reactor could be built that would power a spacecraft.
The next step, already underway, was to develop complete engine technology. This project was called NERVA, Nuclear Engine for Rocket Vehicle Applications. It was to be a combined industry-government effort headed by the Space Nuclear Propulsion Office, a joint NASA and Atomic Energy Commission activity. The principal contractors were to be Aerojet General Corporation and Westinghouse Astronuclear Laboratory. The NERVA technology reactor, given the letter designation NRX, was essentially the same as Kiwi. But now the contractors had to extend its lifetime and put it into an engine configuration. Here is how the nuclear rocket engine will work. The reactor is a solid core, heat exchange type, cylindrical in shape. Fission of uranium atoms in the core is the source of heat. A reflector made of beryllium surrounds the core. The core consists of many graphite elements impregnated with the uranium-235 fuel. The core contains a number of channels running down its length. Hydrogen passing through the channels picks up heat generated by the fission process. The channels are coated with niobium carbide, a material which resists the corrosion that would occur if the hot hydrogen were allowed to come into direct contact with the hot graphite. The hydrogen is stored in a liquid state to achieve the lowest possible volume. The flight model will use about 1/3 of a million gallons for a 30-minute firing. To start the engine, the cold liquid hydrogen at minus 420 degrees Fahrenheit moves through a pump down to the nozzle, through internal passages in the nozzle walls, and back up inside the reactor pressure shell and reflector. This cools the nozzle, the reactor shell, and the reflector, and at the same time warms the hydrogen. The hydrogen then passes through the hot fuel elements where it is heated to about 4,000 degrees Fahrenheit. From there it is expanded through the nozzle to provide thrust. The bleed line carries some of the hot hydrogen back to drive the turbo pump. The whole engine system is amazingly compact for a nuclear power source. The reactor works through fission of uranium-235, which constantly emits nuclear particles called neutrons. When reflected back toward the reactor, these particles will set up a chain reaction, generating terrific heat. The heat is controlled by rotating rods installed in the beryllium reflector around the reactor. The rods are also made of beryllium, but one side is coated with boron, which absorbs neutrons. Initially, the rods are turned so the boron side is toward the fuel elements, and sufficient neutrons are absorbed to prevent nuclear fission from starting. Beryllium reflects neutrons. By turning the beryllium side toward the elements, a point is reached where sufficient neutrons are reflected for fission to begin. The amount of heat produced depends upon the position of the rods. Heat increases as more of the beryllium side turns toward the core. When the desired rate of heat production is reached, the rods are turned back to stabilize it. Heat decreases as the rods are turned back. When the boron side absorbs enough neutrons to halt the fission process, heat is no longer generated. These rods can be operated by remote control.
Test facilities for engine components were built near Sacramento, California. The problem? Get adequate performance with minimum weight. The pump must move huge quantities of liquid hydrogen under pressure at minus 420 degrees Fahrenheit, while the hydrogen-cooled nozzle must expand high-pressure gaseous hydrogen at 4,000 degrees to low pressure. The reactor was designed to meet the structural requirements of ground handling, launch, and spaceflight. In a late 1965 test, it operated intermittently for an hour, including 16 minutes at full power. But in that test, as in all reactor tests before it, the hydrogen had been forced through the reactor by test stand pumping facilities instead of its own turbine-driven pump. In early 1966, the new technology reactor and the chief engine components, including the turbo pump, were assembled for test. It was called a breadboard because they were not arranged as they would be in an actual engine. It would be the first self-starting test, and it was a vital step in the nuclear propulsion concept. This engine test model started perfectly and increased to full power, proving that a nuclear rocket could be started by its own pump. During a 2-month period, it was started and stopped 10 times and operated at different power levels for a total of 110 minutes, 28 minutes at full power. Technology had now advanced to the point where performance limits could be extended. Work was already underway to increase reactor power and operating time. In February 1967, this reactor, the Phoebus 1B, was operated at a power level roughly equivalent to 75,000 pounds of thrust. And in December 1967, this reactor, the NRX A6, was operated at full power for an hour. Also in 1967, a new test stand was completed that would permit a test engine to be fired nozzle down into a vacuum chamber below, at least partially simulating the space environment. In early 1968, the first ground test engine was mounted in the new stand. Its success was a new milestone along the long road leading to a flight engine. Heavy shielding was used in this test engine to protect some of the components from intense radiation. In flight engines, all components will be radiation hardened and less shielding will be needed. These tests will complete the technology for a nuclear rocket engine for application to space missions of the late 1970s and beyond. Its thrust will be approximately 75,000 pounds. For missions that require higher thrust, 2 or more of these engines may be used in a single stage, or several engine stages may be assembled side by side. This versatility will give us the capability to perform a variety of advanced missions.
Someday, a manned trip to Mars and return may become the mission assignment. Exactly how it would be carried out depends upon a number of factors. But here is one way it might be done with nuclear rocket propulsion, using the technology developed for earlier missions. Using several Saturn V launch vehicles, components of the huge spacecraft would be placed into Earth orbit and assembled. Separate nuclear stages might be provided for each major step of the mission. The first stage might consist of 3 clustered rockets for departure from Earth orbit. 2 other nuclear stages consisting of 1 engine each would be used in the vicinity of Mars. The first stage cluster fires to accelerate the spacecraft to the velocity needed to get to Mars in the time that was decided upon, say 200 days. At burnout, the first stage cluster is jettisoned and goes into orbit around the sun. Mid-course correction is made by chemical rockets. About 200 days later, the space vehicle approaches Mars. There it is slowed down by a single nuclear rocket and enters an orbit around the planet. The used second stage is put into a higher Mars orbit than the space vehicle. A chemically powered module departs for the planet's surface. For the first time, men from Earth will set foot on another planet. For the return trip, the module is lifted by chemical power back into a Mars orbit, where it docks with the main space vehicle. The men transfer to the main craft and jettison the module, leaving it in an orbit around Mars. A third nuclear rocket accelerates the vehicle for the return trip. And it is jettisoned. Again, mid-course correction is made chemically. Just before reaching the vicinity of Earth, the crew transfers to a re-entry vehicle and jettisons the large spacecraft. Chemical rockets slow down the vehicle to re-entry speed, and they are jettisoned. After deceleration through the atmosphere, the re-entry vehicle returns to the Earth's surface by parachute. A trip to Mars and back, for centuries a dream of earthbound men, is now much closer to reality. Of course, there are many, many other problems to be solved before such advanced space missions can be attempted. Life support systems for extended space journeys, for accurate space navigation, communication systems, power supplies, and so forth. But any successful advanced mission must begin with propulsion, the power to get there and back. Lower overall weight, larger payloads, shorter travel time. These are the chief advantages of nuclear propulsion. The technology needed to build a nuclear rocket is well advanced. It will be available when this nation determines its next great objective in space.
So, I used to hate that video, and I still kind of do. It kind of stings a little bit, but the NERVA program was reactivated in 2018. The NERVA program was reactivated. They did reactivate it. It was part of Space Policy Directive 3. So that's part of, I think it's the 2017 Transitional NASA Authorization Act. Anyway, long story short, NERVA's back on the menu. They're developing nuclear-powered second and third stages. If I had to guess, they would probably end up on SLS. So SLS with a nuclear-powered third stage could really do some damage. But now the military is investing once again. Yeah, I was going to say, implying that they didn't before? Yeah, no. No, they did. Anyway, so, welcome to Space News, everybody. Let's get to it. Let me start transferring links over here. Alrighty, we got a couple more here and there. I already have that. There's the pictures. There's Dinkelberg's pictures. Those pictures were cool, man. I was checking those out on break. We got some spacesuit news that I didn't share yesterday. That's good. That's good. Explain nuclear thrust engine, please? Oh, the video explained it, Herb, but I'm going to go ahead and guess that if you're asking that question now, you probably didn't see that part of the video, right? So, how nuclear engine works is you have a singular turbo pump. It is a turbo pump, though. You have a turbo pump, pumps liquid hydrogen into a nozzle, cools the nozzle, and then cools the combustion chamber. But here's the thing. A nuclear rocket engine kind of looks like a regular liquid fuel rocket engine. But here's... Actually, you know what? I'll do the plumbing thing in a second. Spacer, long story short, nuclear power releases a crazy amount of energy over time. Okay? So restart now. So say this can right here. It's chroma can. Say this can was a bit of uranium. Like say this was a chunk of uranium-235. First of all, I'd be dead. Second of all, this nuclear fuel has enough energy density. This could power a city if you did it right. If you knew what you were doing, you could get this ball of uranium to release enough energy to generate enough power to power a city. Now, why? Why? Well, okay, we're getting into nuclear physics here. All radioactive material is shooting out neutrons. It's shooting out neutrons at in all different directions. It decays. It goes. You have neutron flux, right? So, what does that mean? Basically, how I like to describe. Picture nuclear material kind of like soda, right? What happens when you open up the soda? It's all fizzly and bubbly, right? And then you pour it in a glass. And what if you want to do something else, you left that glass there. What happens? It fizzles out over time. But it does fizzle. Nuclear material does that, but with neutrons. Okay? That's a good way. It fizzles. It fizzes out over time, just like soda does. I mean, a lot longer time. The rate it goes through what's called radioactive decay. The rate of decay, or the period of time it takes for it to decay into a non-radioactive isotope is called half-life. Okay? So, but that, I mean, half-life is another story. Don't just stand there, Gordon. Pick up that gun and shoot it! So, you have neutron flux, okay? Now, so how does that work with a nuclear power plant? How do you harness that neutron flux? Well, you can regulate the rate of the reaction here, okay? You can regulate, we figured out ways to regulate how much it fizzes, okay? The first way we found to make it fizz out really, really fast is by superheating it. Yeah, you superheat nuclear material, physics divides by 0, and it releases all of its energy all at once. That's the blow up thing. Okay, that's the explodey bits. All right, that's the explodey part. When you superheat these things, you superheat it way past critical mass, and basically it lets all the freedom out. It lets all the neutrons go in one shot. It's an unregulated neutron flux reaction, or just it's called fission, because when a neutron from a radioactive atom hits another atom, it hits it and it knocks it out. It's like hitting pool balls. You know, like you break when you're playing pool. One ball hits it and everything else goes everywhere. And all the neutrons from that atom, it knocks neutrons off of another one, and that knocks neutrons off of another one, and that knocks neutrons off of another one, and it just keeps going. It keeps going until you basically hit half-life, I guess. Not half-life, but it fizzes out, right? So, okay, what does that have to do with NERVA? How the hell does NERVA work then? Well, to understand how NERVA works, you need to understand how a nuclear reactor works. So, what is a reactor? A nuclear reactor, what does that do? It reacts. Yeah, it makes the nuclear material react to things, okay? So, you have a nuclear reactor, and say let's just take a regular reactor, okay? You have nuclear control rods, okay? And nuclear, it basically think like Play-Doh. Like, you know, you push the Play-Doh through the thing and it looks like spaghetti comes out. Kind of like that almost. So you have like a cup, right, which is your reactor vessel, and there's a bunch of holes in it, and the nuclear material's inside, okay? The fuel rods are made out of uranium or plutonium or whatever. Uranium 235, 238, plutonium, different nuclear material has different half-life. You can create different flux with it. Plutonium gives you a much more energetic reaction, from what I understand. I'm not a nuclear physicist, but yeah, that's why they make the plutonium bomb go big. Anyway, so inside of your reactor, when the nuclear material is in the stowed position, it is surrounded by what's called a moderator. What does a moderator do? It stops neutron flux. It bounces the neutrons back at the radioactive material that no, it doesn't bounce it back. It absorbs it, excuse me. It absorbs the neutrons, and it doesn't bounce another neutron. So like lead is a good moderator. Water is a good moderator. Specifically heavy water is a good moderator. So deuterium is what it's called. This is a great way to basically stop. You can curtail the fizzle, right? Just like twisting tighten down the cap on a soda can or a 2-liter or something, right? You'll stop it from fizzing. That's what the reactor does when it's off. Now, when a reactor is on, They take those control rods and they pull them out. They pull them out of the containment vessel. They do that on purpose. That makes it so the neutrons start going all over the place. They start fizzing like crazy. And then what you need to do there is have something that bounces them back. So they just keep bouncing back and forth and bouncing back and forth and bouncing back and forth. And then you're basically regulating the amount of atoms that you're splitting. By a neutron hitting one atom, it splits and goes to another two, right? So the more you pull the control rods out, the more surface area of nuclear material you're introducing to this pinball machine of neutrons, if you will, right? And what they do, what a nuclear power plant does with that is they do this in water. It does in water for the most part. When they pull them out, it's submerged. And what it does is it heats up the water, and it heats up the water into steam. And that steam goes and turns a turbine, steam turbine, right? It goes and turns a steam turbine. That steam turbine is attached to a generator, generates power. Simple as that. The water then goes through a condenser, right? It goes through a condenser to go from steam back into water, and then it gets fed back into the reactor via a pump. Now, that condenser, it's important to know this. That condenser, where the steam that's coming from the nuke, right, that goes in there, that condenser is attached on a separate coolant loop. So you're not exchanging radioactive material into the atmosphere. They have a dirty coolant loop and a clean coolant loop on a nuclear reactor. This is every reactor does this because you don't want to spew out radioactive water into the lake next to you, right? That's probably not a good idea, right? So how does that pertain to nuclear propulsion? Okay, so remember, you have your rate of reaction, so neutron flux, how much energy you're making, literally. That comes by demoderating a nuclear reaction. And then what the nuclear engine does is it doesn't have axial control rods, okay, that go in and out of a reactor. You have a reactor, and then you have radial control rods. So they're a control rod that looks like just basically a long bar, but it's half of it is on the nuclear engine, half of it is beryllium and the other half is boron. Can you guess why? So you have your nuclear material, you don't pull the nuclear material in and out of the reactor. It just stays in the reactor. Now you have control rods on the outside, and they twist the control rods, and they expose half of the control rod is boron, and the other half is beryllium. Do you know why? I already said the answer. It should be pretty easy. Yes, subs. Yeah, just like that. Well, one is a better moderator than the other. Beryllium is really good at bouncing neutrons back and causing more atoms to split. Boron absorbs neutrons, so that contains the fizz. The other one shakes the 2-liter up and lets the cap go, you know? So with a nuclear engine, you have that reactor that I just described with radial control rods, right? But that reactor is inside of a rocket's combustion chamber. Okay, so it's inside of the rocket's combustion chamber, so that means you have your injector plate up at the top, and your injector plate is shooting hydrogen into this nuclear reactor. I know, it sounds ridiculous, right? And then at the other end of the reactor, you have a funnel, a throat, and a nozzle, just like a regular engine. So, what happens? You inject hydrogen, liquid hydrogen, into the nuclear reactor with beryllium exposed. What's going to happen? Well, the hydrogen is going to intersect with the neutrons going back and forth between the beryllium and the radioactive material. They're going like this. Hydrogen is going to intercept it, and it's going to hit it, and it's going to heat up the hydrogen because it's going to split some hydrogen, and it's going to release a lot of heat energy. All right? So the hydrogen heats up. What happens when you heat up a gas? This is easy. Come on. High school physics here. What happens when you heat a gas up? It expands, right? It expands like crazy. The nuclear reactor heats up the hydrogen so much and so fast that it's enough to create combustion chamber pressure. And then they just shoot it out the throat and the nozzle. The rest is just basic rocket science. Basic rocket science. Basically, you can pressurize the combustion chamber. And just like any other rocket, a rocket is just basically a pipe bomb, right? But with a funnel on the end instead of two caps, right? And it shoots explosives out a throat. That's it. That's all it does. It's very simple. And so if you want to know how they get the hydrogen too, that's where the plumbing thing is. That was the first thing that I explained. And then I said, forget about it. So the nozzle, or inside of the combustion chamber and the throat, there's a tap off. And that takes some of the heated hydrogen and it spins the turbo pump, and that pumps liquid hydrogen in. And then they use liquid hydrogen to cool the nozzle and the combustion chamber. And then that liquid hydrogen circulates around and hits the injector plate. It's very simple. It's really not complicated. It's just a nuclear reactor with radial control rods jammed inside of a rocket engine. That's it. No oxidizer needed, just hydrogen. That's all you need. Now, why hydrogen? Hydrogen's very conductive of heat. It's very good at it. Very good at conducting heat. Yeah, probably one of the best. I think the only other thing that even comes close is helium. But hydrogen's a lot more plentiful than helium is, isn't it? Yeah, hydrogen is also pretty light if you're going to take the mass of the gas into account. Sure, absolutely. Yeah, this technology, they had it working in 1967. It worked just fine. It still works. Physics doesn't change, but we reactivated it. And we're going to have nuclear-powered stages in the future if everything goes right. Yes, I will knock on wood. Does that make sense? Basically, nuclear material likes to fizzle. It fizzes like soda. How long it fizzles for is called half-life. What it's doing when it fizzles is shooting out neutrons. When a neutron hits an atom, right, it splits. It knocks the neutrons off of that atom and it splits the atom. Splitting the atom releases insane amounts of energy. We know it releases insane amounts of energy because nukes. That was the first time we regulated a nuclear reaction, if I'm remembering right. Well, yeah. You can either slow cook the freedom and let the freedom out in ways of generating power, or you can flash fry the freedom and let all the freedom out at once. You don't want to that second way, that's not really a good way to do things. Half-life, does that mean it's only half as dangerous? I forget what half-life means, dude. I'm not a nuclear physicist. All that's self-taught. I got really interested in nuclear physics after reading about Chernobyl, believe it or not. And then the miniseries came out and everybody became an expert on it. So doing all that reading about it actually paid off. Thanks, EJ. I learned something new and I'm better for it. Yeah. Nuclear physics is cool, man. It's really cool. Yeah, half-life is the time it takes for a given sample to get to 50% decay. There you go. 50%, yeah, half-life. Yep. No, it's hot. Yeah, you're not wrong. Dude, I like to think that I know a good deal about physics and stuff. Out of everything, nuclear physics is just weird. That's just weird. That's weird that, it's like water, dude. Water shouldn't exist. It's like, okay, water is like the only thing that expands when you freeze it. It goes into ice. It's very strange. Two hydrogen and oxygen. It's very weird. Not a lot of liquids work like that. It's very peculiar. The fact that water exists is very strange. Nuclear is another one of those just strange things, dude. It's very weird. It shouldn't do that. It's just fizzing out neutrons. That's what it does naturally. Yeah, it's weird, right? No, I never said it wasn't. I never said it wasn't straightforward, Endo. It's just strange. That's just strange. Like, look, I have aluminum here. This aluminum isn't going to heat itself up. Nuclear material just heats itself up. That's very weird. Does anybody else find that a little weird? Like, yeah. If I understood correctly, a nuclear rocket with a nuclear engine will produce minimal amounts of radiation in operation. Yeah, pretty much, Yamaha. Yeah, it's not too bad. I mean, okay. Two things. Yeah, it does produce radiation. No, it's not a lot. The radioactive hydrogen that comes out of the back of a nuclear engine has a very short half-life. It decays very quickly. So you don't need to worry about it messing you up. I mean, don't stand in the exhaust, which is mostly the case for most rocket engines, right? So it's not too bad. Like, honestly, it'll just decay before you get like radioactive fallout. Second part of that is, well, using a nuclear engine in space and worrying about radiation is like using a water jet to power a boat and worrying about getting wet. What are you going to do? Make the ocean wetter? What are you going to do? Make the lake more wet? It's not really how that works. Space is already irradiated to all hell, so it's really not that big of a deal. I'd just be more worried about putting something that bounces the neutrons away from the people that are on board. I prefer my lakes to be wet. Mm-hmm. Yeah, most do. But you can't make it more wet. Space is already irradiated like crazy. It just happens. Like, it just happens to be that we found a way with an engine that makes tons of radiation. It is what it is. Problem is when your launch vehicle blows up on the pad. Well, the nuclear engines are already pretty contained, dude. I wouldn't worry about it too much. And for the people that are wondering, like, oh, but what if they launch it out of Florida and it goes into the ocean? Isn't that bad for the ocean? Yeah, it's probably not good for the ocean if, like, a rocket with a nuke stage, like, had a rud or something and the nuclear material fell into the ocean. It's probably not good, but it's not bad either. Okay, I will explain why. So, one, if there's nuclear material at the bottom of the ocean, the water's actually a pretty damn good moderator, so you don't have to worry about it fizzing too much. That and pressure kind of just keeps it okay. How do I know that? Well, in the 50s, the U.S. had a little bit of a mishap where a plane with a nuke attached to it went down and the nuke fell in the water. They were like, maybe we should go get that back. And then they realized that it's really not that big of a problem because no one can get at it because it's not impossible to get to. So nuclear material, believe it or not, is actually pretty stable at the bottom of the ocean. It's not going to like fizzle and cause it's not going to cause like Godzilla to happen down there. It's not really how that works. You wouldn't start the nuclear reactor until you're in the vacuum at least. You can fire them down here, Lego. It's not that big of a deal. I mean, I wouldn't stand near the exhaust, but like I said, that's mostly the case for most rocket engines. You don't really want to be near them when they go off. I mean, I kind of do, but you wouldn't start it. All right, I already got that. Aluminum makes a great radiation blocker. Yeah, remember, guys, it's not about absorbing the radiation. If you're trying to rad shield a spacecraft, you want something that's a bad nuclear moderator. Think about it for a second. Making a spacecraft out of lead up in space is like making a boat hull out of sponge. It's not going to work very well. You're going to get wet because you're absorbing water, not bouncing it. This is why all of the Apollo astronauts, after they went to the moon and got pretty badly irradiated, lived just fine. Buzz Aldrin's still alive. Still alive. 50 plus years on, right? They're fine because they were in an aluminum spaceship. This is one of the things that they figured out during the Apollo program. This is a secondary science experiment. They dipped the spacecraft through the Van Allen belts to see what would happen, which is It's a little ballsy to do with people inside, but hey, whatever. RTY, how are you? Yeah, aluminum bounces. It bounces radiation very well. It actually protects the crew more than a lead-lined spacecraft would. Lead would be bad. You'd be absorbing radiation. You would get more irradiated that way. So, yeah, I mean, nukes in space are a great idea. Not nuclear explosions. I think nuclear explosions are Bush League. That's Bush League. I don't. That's. You know, any. This is gonna sound stupid. Any idiot can superheat nuclear material all at once and cause it to basically flash fry and explode. That's Bush League stuff, man. How about getting one to power a city? Now we're talking. Now that's hard to do. I think that's cooler, personally. Destroying things is Bush League. If you really want my honest opinion, anybody can destroy something. It takes skill to build things. Pinky out, baby. Pinky out. Anyway, so how about we jump into space news? Good talk about nukes. Nuclear powered trains when? Well, Lego, down here you have this problem. Down here, the problem that you have is that, well, Earth's magnetic field absorbs a vast majority of radiation. Now, it doesn't get all of it. If you still go outside, you're still going to get sunburned. That's what happens. Ask me how I know. Ask me how I know. Anyway, the thing is that if you have like a nuclear powered train down here, you would have to find a way to basically contain the flux. That's the part that's not good for you. Anybody riding in the train is going to get irradiated. And a locomotive that would be big enough to hold nuclear material like that would. It's like the means don't justify an end in that regard. You could have a nuclear locomotive, but all the rad shielding that you'd have to put in would make the locomotive so incredibly inefficient it would outweigh the benefits of having a nuke. It really would. That's so much more mass that you have to move, and it doesn't outweigh the efficiency. You know, the efficiency gains that you get. They tried this in the 40s. They tried nuclear-powered steam turbines, if I'm remembering right. They also tried it with airplanes. There was a B-36 that they equipped with a nuclear reactor, a compact nuclear reactor in the back of the plane. And what they basically concluded is that that plane could fly indefinitely. It could fly forever. You would never have to refuel the thing, not for years. 20 years maybe. You could just have the plane just... But the thing is that the crew would pretty much be ghouls by the time you were done. I mean, don't get me wrong, you could rotate crews off, but if you're going to rotate crews off, that means you have another plane that flies to the plane in the first place. Why not just land the plane? Why not just land the plane? It doesn't make any sense. I mean, think about it. You have a nuclear-powered plane that can just fly forever, right? You're not going to leave one crew on it for 20 years, right? So you got to rotate the crews, right? And if you're rotating the crews, you have to get a bunch of people in a plane and fly them to that plane, somehow rendezvous with the plane while it's flying, which, I mean, I'm not going to lie, that'd be kind of cool. They should probably do that. And then get the people in the plane and get another crew and then leave. You have to fly a plane to the plane to swap the crew. Why don't you just fly the plane back and then just refuel it and fly it again? That's what they figured out in the 50s and the 60s. That doesn't make any sense. That's super complicated logistics. Why would you do that? See what I mean? That's just not a good idea. Would be better for recon UAVs. Yeah, Gaffley, I'm not going to sit here and pretend like, somebody hasn't thought of that. Somebody probably has, dude. I'll bet you they have something like that. I think that would be a fair assessment. I mean, heck, if you made a light enough reconnaissance plane, right? You could, just like the Dark Star in Flight Sim, with a hydrogen fuel cell and electric engine, it could stay up there for a really long time. I would call that unsustainable. I see what you did there. I see what you did there, Zim. Nice. It makes sense if you want to have a plane in place where fuel is hard to get, say like Antarctica or something, I guess. Why don't you just use a submarine then? Which, spoiler alert, that's what they did. Yeah, that's what they did. It makes much more sense to do it on a boat, because you could put in the necessary rad shielding around the reactor inside of the ship. Would we have the technology to remote control a plane from the ground, so no need to change the crew for the nuclear plane? Yeah, of course we could. Yeah, like you're talking about like a UAV bomber or something? Yeah, I suppose. Suppose that could work. Why wouldn't it? I have an idea. Use it for a probe on Mars and take a helicopter with it. See? See, Bright? That's where I'm at. Why have uncrewed nuclear bombers when we could have uncrewed nuclear-powered airports on Mars? I like that one better. That takes more skill to do. That's the higher difficulty, if you ask me. It's my boat. Anyway, let's jump into space news. Check this out. Ursa Major is a rocket startup company, right? They posted some pretty gnarly pictures of this thing. Speaking of going fast, that's pretty neat. So this looks like something that's going to be used to test hypersonics on Stratolauncher. That's what it's designed to fly on. It's designed to fly on Stratolauncher. That's called the Talon A. And it has an oxygen-rich stage combustion cycle engine on the back, which is pretty cool, actually. Is that the X-15 tail fin? It does look like it, doesn't it? It looks like a shoe. I like it better from this angle. The other angle makes it look silly. This looks silly. That looks cool. You know what I'm saying? I think that looks way better. It does give off some X-15 vibes. It's kind of designed to do the same thing. Yeah, that thing though. Did you see this? Stop yelling at me. Starting soon, are we? Oh, hey, EJ, you left the starting soon thing up. Oh, thanks, drummer. Yeah, here, I'll shut it off. Thank you for being courteous about... Oh, wait. You weren't. Side note, Phantom Space has ordered 200 engines for Ursa Major. Wow. Well, that's pretty neat. So that's cool. We got a hypersonic test vehicle. I'm not sure what Talon A is supposed to do other than go fast, but hey, still pretty cool. Phil, what's this picture? Oh yeah, this picture from yesterday. Yeah, that's a real picture. That's a real picture. Taken from the space station remote manipulator. Yeah, Rover dude, I don't hate it. How are you, man? I don't hate it. That's pretty neat. Yeah, you could tell they're spaceships because of the way it is. That's pretty neat. I'm busy with secret stuff. Ah, yes. Super secret squirrel stuff. Yeah. Secret squirrel? Or are they over, though? That's the Baja Peninsula, I'm pretty sure. Those docking adapters sure are ugly. No, they're not. They're not ugly. They're not ugly. They're They're bent for a reason. Not KSP stuff, though. Well. And let me guess, you can't say what it's for. Okay. That's cool, man. Right on. You're working on a new game. KSP 2? Oh, I'll be doing some modeling streams live soon. Oh, cool, man. EJ, you're not going to believe the truck I work on this afternoon. Truck. Hit me. A 95 F-250. You got any pictures? Oh, yeah, you got pictures. What the hell? What? Bill, what the? Heh, no Kerbals in this one? No KSV2? Well, that's cool, Rover, dude. Okay, can I ask who you're working for? Or... you're teasing it, now you've piqued my interest. That's awesome. How does that even, dude? That's so strange. It's even the right color red. That's so weird, man. 100% indie. Some announcements coming soon. Cool. I think that truck is called Weak Enough. Yeah, Ian, that truck's cooler than mine. It's got all-wheel drive. That's a 4x4. Mine's just a 4x2. Bill, that's awesome, though. Pretty cool. That's nice, man. No rust either. Wow. That's a really nice bed, really nice body. The rear tank is missing? That's weird. Why are all the beds white? Fleet vehicles. That's just strange. Let me see if I have a picture. What's that, Rover, dude? Oh, cool. That's cool, man. Here, let me see. Let me take a look. What is this? Have you seen your truck lately? I drove it around over the weekend, Illness. Yeah, got to drive it all over the place. Truck runs fine. Tough Enough runs great. I haven't had to do anything to it in a long time. I just changed the oil a couple of months ago, and I bled the clutch. The clutch hasn't leaked, so it's not leaking. It just ran out of clutch fluid when we had the problems with it before. Clutch still works just fine. Everything works great. Nothing. Yeah, that truck's given me no problems, which is kind of crazy because I beat the trash out of it driving it across the country. Love the work you do with KSP. What year, Rover, dude? Here, I'll just show you. It looks like the one that Bill just linked. It looks like exactly like that, only it's a 4x2. Here, just Twitter. Go to media. I got a picture of it in here somewhere. There it is. It's weird because... Okay, it's not exactly the same color red. Yeah, Rover, dude, I bought this from Hoonigan in California, and then promptly streamed driving it back. I streamed driving it across the entire country. Yeah, across the whole continent. Yeah. Yeah, Route 154. Took 2 weeks. Drove it 4,000. Pretty much, it was about 4,000 miles, give or take, because we did do some stuff off the beaten path. We went to the Grand Canyon. I proposed to Bremo there. That was kind of important. We drove it to Vandenberg. This has been by the pads at Vandenberg. I drove it. We drove it from Vandenberg back to California, back to Los Angeles on a shakedown, and then Los Angeles to Vegas, Vegas to Flagstaff, Flagstaff to Santa Fe, and Santa Fe to Amarillo, Amarillo to Kansas City, or no, Oklahoma City, excuse me. And then we did Oklahoma City to Detroit. Yeah, that was a long way. And then Detroit to Boston. We lost a tire in Oklahoma. That's why that rim is gray. Yeah, the ring thing was important. Yeah. Mm-hmm. The lugs broke. It's not a hub-centric rim, so if one of the lugs backs off or something, or the rear end gets something jammed in the gears. Oh yeah, that's right. I forgot about Indy. Thanks for this. But yeah, Rover Dude. Yeah, I drove that truck across the country, the entire country. It's a 5-speed, dude. 5-speed with a 5.8. It's a 97 last year for that truck. Yep. It's fun, man. Hey, Bill, I got a question. Did that truck that you work on have twin eye, or did it have a solid front axle? Yeah, Rover Dude, it's pretty cool. I always like these trucks. These old Fords are really nice. They're really cool trucks. I also upgraded it along the way. Mine had a painted grille and a painted bumper. I swapped it for the XLT stuff. It's a TTB F250. That's what I want, man. Have you seen Jerry Rig's electric Hummer that he's building? Yes. Yeah, Bill, I want to put TTBs in this thing, with front wheel drive. Blood fam, so you got a message from your Navy friend? Oh, about that thing? Yeah. All right. Cool. But yeah, Rover Dude, it's a nice truck, man. It's a nice truck. I want to use it to drive down to launches. That's what we're gonna do. That's kind of on hold right now because house stuff, but whatever. That man should be kneecapped for putting EV parts in a second-gen military Humvee. I mean, Jim, it's cool if you want your Humvee to be less reliable and less good at its original intended purpose, I guess. Size up something like that. You'll DM me after dinner, Blood? All right, man. All right, cool. Sounds good. This thing saved your damn life. I mean, that's what I mean. You know, it's funny how people take things that are designed for purpose and then modify them in a way that makes it less good at that original purpose. Squatted Trucks, I'm looking at you. I mean, yeah, let's just modify it to do less and be less good at the thing it was designed for. That's great. Brodozers, yeah. You see those big lifted trucks that have like 25-inch rims on them that are, they are hand polished every day because, let's lift it to do all the fun stuff that we want to do off road and then never take it off road. Let's just modify it to make it worse at what it does. That's good. All right, cool. EV parts are awesome, way more efficient and a longer life. In a military Humvee though. In a Humvee? I don't think that's gonna work very well. Don't get me wrong. I'm not trashing EVs. It's just putting that into a Humvee is. All right. I'm so glad you can't squat trucks anymore. Yep. Drummer, guess what I saw today? A modern Defender pickup truck. It looked so out of place and too American. No, that's just. No. That's just you. That's just you pretending to have delicate British sensibility. It's not practical. A pickup truck is the most practical vehicle ever devised by man. Not a fan of the new Defenders? Yeah, me neither, dude. I mean, they look cool, but it's not a Defender. It's a... I just did the rebuild of the transmission on your Land Rover Series 3. Thoughts on Rivi? I don't mind electric vehicles, Ian. That's fine. I really don't have a problem with that. I can't imagine doing it on a modern vehicle. Yeah. Rover Dude, you did the transmission yourself? That's cool, man. Pickup trucks are good if you're a scrap man. Pickup trucks are just good at what they do, Lego. They're not very fuel efficient, but they make up for that by being useful. That's why I like pickup trucks. That's why I like them. It's like how James May likes small vehicles because they're practical and sensible and they're good at what they do. I agree with him on that. I like pickup trucks because they're practical. They're good at what they do. I don't like brodozers. Brodozers are useless. Oops, 96 Caravan. Nice. Can't pick up chicks in a tank. Yep, strip down every nut and bolt. That's awesome, man. Oh. Oh, that's... Oh, no. Yeah, okay, drummer. Yeah, no, that's just strange. See, I like old trucks like this. This is not designed to be a luxury vehicle. It's designed to do work. And it's designed to be reliable because it's designed to work out on a farm where you don't have any parts for like 100 miles in every direction. So it has to stay working. That's why I like trucks. I don't like trucks because Mr. America loves trucks over here. No, I like trucks because they're useful. You use them to do things like a bulldozer or a tractor trailer or something. What's your take on Rivian? I don't mind Rivian. Yeah. Hey, bed cover. Yep, I put a tonneau on it because I have a bunch of parts stored in the bed. Yep. And that truck, this truck is as bare bones as you freaking get. It is bare bones. 5-speed, 4x2. I want to make it 4x4 because that would be cool. No bells and whistles. Just a good freaking work truck. That's why I like Tough Enough, and that's why it is a kick butt. It has kick butt potential for being a streaming vehicle, because those old Fords, you can't break them. Those OBSs are great. They're a great design. The design that came after them is junk. Yep, fleet vehicle. Yeah, baby, gotta have it do work, man. Are you following the Monroe and Associates Rivian truck teardown? No. I have a soft tonneau on my cup. On your cup, nice. On my truck, it adds a lot of practicality with pretty much no downside. Yeah, the tonneau, with the tonneau built, well, dude, it's a bed from California. I didn't want it to get messed up. It has no rust on it. And I haven't winterized that truck yet. Watching Monaco and Daytona? Monaco, Daytona, and the Indy 500. Ooh. Yes, I love a good truck. Ooh, a Morris pickup truck. Nice. Yeah, serious. This is the best weekend of racing. Last week of May. You got Monaco. You got Monaco. You got Indy. You got the Coca-Cola 600. It's just great, man. Daytona, it's Charlotte. Alleviate, it's Charlotte. It's Charlotte, sorry. Misspoke. Oh yeah, Daytona's in July, that's right. Seriously, still thinking you're going to 23 Miata. Yeah, that's cool. Yeah, Buck, I don't know. Spaceflight has taught me a thing about engineering. And what spaceflight has taught me is that stuff is built for purpose. You should build it for purpose. Don't try to make something that's going to do everything, because you're going to make a piece of junk. I mean, the time NASA did try that, it was a pretty damn good attempt, all right? I will say, it was a pretty damn good attempt. But it's better to have purpose-built vehicles. I think it's better. They're vehicles that have purpose. I like vehicles that are built for purpose. The shuttle wasn't junk. It was pretty damn good for a first attempt. All right, drummer, see ya. I mean, Danny already nipped the wall in an FP2. He wanted to go swimming. And he went swimming into the barriers at swimming pool. Buran was better. Hey, can I copy your homework? Yeah, okay, copy my homework. Just change things up a little bit. Do you understand the analogy? Do you understand the analogy? Yeah, I saw what happened to Colton. I'm glad he's okay. Anyway, that's a cool truck, Bill. And yeah, Rover, dude, that's cool that you worked on the transmission, dude. And that new game looks pretty sick, man. Indie project, huh? It's pretty cool. How many missions did Buran fly? One. Whammy. Yepers, fun stuff. Yeah. Hey, Bill, you still here? If I go source myself some TTBs from the junkyard, you wanna come down here? What if we get the house? Stream working on it, do it in a weekend. Get some 4-wheel drive up in that mother. It'd be a good truck for that. It's so... Because that, dude, it's a California truck. No rust. There's no rust on Tough Enough. There's nothing. It's crazy. I was checking out under it today. Seems pretty bolted. It should be fine, dude. Yeah. Yeah, I mean, once again, they made those trucks pretty dang modular. It was unbelievable how much distance it took for me to pull a right turn to KSC at Mach 9. I crossed Georgia, South Carolina, North Carolina, and went about 500 miles over the Atlantic before I came in from the Northeast. Yep. Heading out. Talk to you later. All right, Rover Dude. Yeah, that's cool. Thanks for popping in, man. It's good to see you. Don't be a stranger. Oh, Rover Dude, just on a side note, dude, when I say don't be a stranger, I mean it. I found some really despicable things to do in KSP. I figured out a way to get non-driftable hinges. We figured it out. So we can do some despicable stuff. We'll hop in soon? Alright, man. Hey, it's good to see you. Alright, anyway, back into space news here. So we got into the flying shoe right there. That's cool. Got shots of 2 commercial cruise spacecraft there. Starliner, of course, has completed his missions. That one is down because the Dragon that's up there is for Crew 4. Crew 4 is going to be down not for a little while. So there's another picture of Talon A sitting on the pylon mount for Stratolauncher right there, which is pretty cool. Looks like they were doing wind tests with it. See all the strings that are hanging off the sides there? Miller got the 440 and the 727 back in the race truck for this week. Took it for a shakedown today. Nice. I have July off. You want me to source you some parts? I don't think it depends, or not. I don't know if we'll be able to afford it. Captive carry testing. Whee! Yep. Okay. All right. See. So here we go. Let's look at some footage from that.
Talon A is a reusable hypersonic testbed. It represents a new chapter in hypersonic flight and builds on the legacy of the X-15's achievements from the 1960s. The Stratolaunch team has completed the first integration of the Talon A vehicle to our carrier aircraft, Rock. This is a critical step in providing our nation with routine access to the hypersonic flight test environment.
Not bad.
Talon A is a reusable hypersonic testbed.
Cool. All right. Well, that seems pretty neat. Should fly it into space. That's a big plane for such a little guy. Yeah, Stratolauncher Rock can move way bigger stuff up into space. All right, anyway, next bit of space news here. So this is coming from Eric, but this is from the press conference that happened when we were playing Flight Simulator. So, here. Cliff Lanham, NASA EGS program official, says NASA's targeting June 6th for the rollout of the SLS rocket to the launch site for the next wet dress rehearsal attempt. Current target for the beginning of the wet dress rehearsal test is June 19th, but Lanham says that the date is subject to June weather in Florida. RIP. Food for thought. I want to know if you're interested. Well, I mean, Ernog, if you want to go around the horn, go get the parts at a damn junkyard. Yeah, maybe. Got to source all those parts. But yeah, we'll figure it out. All right, cool. So it looks like they're done tracing the fault tree analysis from the first wet dress rehearsal that happened a month ago. And it looks like we're going to see another rollout soon on June 6th. That's a good day. Good day. Pretty historically significant. Am I right? Pretty historically significant. It will be significant. Yeah, Ernak, we'll talk about it though. So, that's pretty cool. We got EGS happening there. And then he killed the dog. So, I am actually going to listen to the rest of that press conference. We don't need to do it now. We can do it some other time. So let's go over to the next bit of news. Launcher 1 has left the factory. Okay. Yeah, you linked this already. But we can watch it now. You must be all antsy in your pantsy to watch it. Here, let's go. That's pretty cool. I forget, Ivan. We got to like 20. I think I beat the 20 minutes thing. But that's pretty cool. I know exactly where that is. Which is pretty neat. Here, if we go into good old media here. Give it a second. Give me a second. Give me a second. Hey! There it is. You little meat. Yeah, see? Oh, the truck's also in the picture, but yeah. What? What? Jebs. It says Jegs. Little Jegs logo hiding under there. Dude, I still need to take the frickin' bed off and put the gas tank and everything back in. We haven't done that yet. Dang it, Bob, something's loose under the car. Yeah. Did I tell you guys the story of how the shop in Oklahoma that pressed new lugs into the back left wheel to get me back on the road made fun of me for that exhaust? Ever tell you that story? Oh, yeah. They're like, hey, man, I think something's wrong with your exhaust. I'm like, oh, yeah. That came apart. I put it back together on the road, and they're like, oh, gee whiz, you think? I'm like, yeah. Are you making fun of me? Yeah, that actually happened. Yeah, they were, the tow truck driver and the auto mechanic, yeah. They were like, nice exhaust, man. I'm like, okay. That's good. Do you think they'll ever do truck in space? Sure. Space trucking? Dude. Yeah. Hey, worked really hard to cut those pipes off, dang it. Yeah, that exhaust fell apart. Actually, it fell apart after Oklahoma. It fell apart in Indianapolis. Yeah. It was on stream, and I was just so over it at that point, I just ripped the exhaust off. It was like hanging by a thread. I just ripped it off, threw it in the bed, and just kept going. I was like, I'm over it. I'm over it. Yeah, yep, multicolored Ford, that's right. Oh, man. You know, if we had a space shuttle, we could take the truck into space and bring it back down. That's all I'm saying. It'd be pretty cool. When are we racing? Racing usually starts around 9. Anyway, let's see what else we got here. Let's take a look. ULA, so... Welcome to Cape Canaveral and the start of another Atlas V launch campaign. Follow along today as we begin stacking the rocket to launch the SF-12 mission directly into geosynchronous orbit 22,000 miles, 36,000 kilometers above Earth on June 29th. Hey, another Atlas. That's pretty good. Yep, this is the Atlas Space Operations Center. We flew over the ASOC when we flew over ASOC when we landed the Dark Star this afternoon in Flight Simulator. Oh, yes. 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 Too bad the VOD is missing? What do you mean, Hell Hydra? That's pretty dope, dude. Look at that thing. Sorry. Yeah, I'm just looking at the picture. I like that they redid the railroad tracks to move mobile launchers down them. That's pretty cool. Yep. Cool. They posted more stuff. Let's see. What did ULA also say? Oh, hello. That's pretty neat. Oh. There's no active VOD right now today like there normally is. Maybe it shelved it because of the maybe it shelved it because the Top Gun stuff. The Top Gun stuff probably got very, very mad. Or the Twitch probably got very, not Twitch, but you get the idea. He probably got little PO'd at the Top Gun stuff. Let's see, let me take a look. Nope. No strike. Interesting. Wonder what that's about. Wouldn't matter though, the VOD would still be there but muted. No. There's this thing that where it like shelves the VOD or something. Drummer was telling me about it, I remember just saying something, but he went to sleep, so. Yeah, it's this thing, it shelves the VOD and what else? Like, it makes it not clickable if it thinks there's like copywritten music or something. Site Flimulator, yep. But yeah, there's nothing crazy over there. On YouTube, it'll actively stop your stream until you change the song, which is odd. Yeah, whatever. Anyway, that's pretty neat. Cool. Summer interns, man. What a shot. Damn. Yep. License for the game, not for the stream. Because... Anyway, alright, what's the next bit of news? This next bit is coming from Space Systems Command. Space Systems Command ordered 8 national security space launch missions from our industry partners ULA and SpaceX for 2024. Oh. How many? Space Systems Command ordered 8 national security launch services under the NSSL Phase 2 Launch Services Procurement Contract today. 5 to United Launch Alliance for GPS-3 SV07, SF-23, SF-43, WGS-11 Plus, SF-16, and SF-16 using the Vulcan Centaur launch vehicle, and 3 to SpaceX, SF-124, SF-62, and 1 SDA Tranche 1 mission using Falcon 9. So ULA got 5, SpaceX got 3. Interesting. What do any of these missions do? Don't know. One is a composite of takeoff and landing from Slick 4. The other one is some 3D graphics. You just crudely pasted Vulcan over an Atlas V. You just crudely pasted your face over mine. Why do you want to listen to the radio when the television's on? Because I like to party. Anyway, that's cool. Vulcan has more missions stacked up for NSSL, which is pretty sweet. Man, Vulcan's manifest is going to be insane. There's... Seriously, they're going to be launching like once every 2 weeks or something, I think is what... Bad. It's just, I think that's what Tori Bruno said. If it ever gets engines... Oh, I like that one. What's Brimo yelling at? I don't know. She's playing Minecraft or something. Like, what about that one, Jim? Only 2 years late. I guess. I guess if you want to look at that like that, that's fine. Oh, they got the engines. They got the engines. And billions of dollars over budget. What? What are you talking about, man? I don't ever remember us getting budget for the BE4 unless you know something we don't. Unless you know something we don't. Chat says hi. Chat says hi. They can hear you. You do through friends in the defense industry. Jam, your last name isn't Berger by any chance, is it? Check this out. SpaceX posted this today. Are you sure? Can I call you Jamburger from now on? Can we do that? Jamburger. Dude, I mean, Jam, you want to know the honest truth? Stuff takes time, man. Takes time. Everything is over budget. You know why everything's over budget? Because the real truth is that nobody knows how much this stuff's going to cost. No one knows how much it's going to cost. You don't know what the price is going to be until after you paid it. When you go to buy a car, what if you buy a car and it breaks? That's added cost. You might not know how expensive it's going to be, right? Right? I mean, what I'm trying to say is that even if you do know that the BE4 is over budget, I'm willing to bet money that SpaceX has sacked more Raptors than Blue Origin has. Point is that, dude, everything is going to be expensive. Nothing in aerospace is on time. Nothing. Do you want to know why Apollo 8? Do you remember Apollo 8 where I put a bowl of pudding down my pants because I was 5? No. Apollo 8 flew with no lunar lander. Anybody know why? It's important to the subject matter. Grumman wasn't ready. They weren't ready with a lander. Straight up. Because building lunar landers takes a long time. Because they knew humans would YOLO. Yeah, they were behind schedule with the lander. This stuff happens, man. It happens. And unless you're willing to throw copious amounts of money at the problem, it's not going to happen fast. Like an Apollo program budget is what I'm talking about. You did what? I did nothing of the sort. Is the Pope Catholic? It's as easy as falling into a bowl of pudding. Anyway. Stuff takes time, dude. I wouldn't knock Blue. What they're doing is pretty damn impressive. And New Glenn should pop up a lot faster than you might think. It's just going to take time, though. It's just going to take less time than you think, but more time than you think. That's the catch-22 of it. You guys ever read that book, Catch-22? You can't admit that you're crazy. Because if you say that you're crazy, that means you're not crazy, because at least you acknowledge what crazy is and you're cognizant enough to know what's crazy and what isn't. So if you say you're crazy, you're actually not crazy. Yeah, put that one in your pipe and smoke it, Jamburger. Jam, I'm just messing with you. You're probably right, to be fair, but I think it would be prudent to say that the people that control the purse strings for Blue Origin have deep pockets. Boop. Anyway, Ship 24 rolled to the pad yesterday. What if I say I'm not crazy? Yes. Well, if you're not crazy, then you're obviously not crazy. You know what? These pictures are really nice. A really nice picture. I'd argue that everybody's weird, and like there is no universal size for clothing, there's no such thing as normal. The Catch-22 thing is satire, Inco. Let's see what we got here. Oh, man. Did I see Tim's video? I did watch Tim's video last night. Yeah, I watched it. Tim lives a very gifted life, man, but he's worked for it. That guy does work. He's one of the hardest working people that I know in this industry. Yeah, that video is amazing. Can we go up the tower? Sure, why not? What? I like how they seem to use crane counterweights for everything. Yeah. If the boot fits, man, you already have them. Just use them. They're right there. I still can't believe this. Okay, there's a part where Tim and Elon in his video are just sitting up on top of the catch tower, and Tim asks Elon like something about like introspection and like how surreal it is and how no, what did he say, like philosophical, and then there was just kind of a moment where Elon's like, you could tell like the gears were turning. He's like, wow, this exists. That's weird. And I'm like, dude, this is your brainchild, man. What do you mean? This is your brainchild, man. What are you talking about? I thought it was funny because even he's like, wow, this is a thing. This is a thing that exists. You see how thick that steel is made up of the tower. Dude, is that thing nuts or what? It's unbelievable how big it is. You know what? I don't want to watch Tim's video on here, so how about we watch the animated version of that? Coming from our buddies over at NASA Spaceflight, baby! Oh, they took the hood off. I got space trucking stuck in my head now. That elevator ride seemed a little sketchy. It's a temporary elevator, dude. My hands got sweaty when he pointed the camera down the center of the tower. Yeah, it was crazy. That's nuts, dude. When is the Starship orbital flight test? Is that a thing? I think they're going to try to hit the end of June, Crustacean, but I could be wrong. That interview is so good because it seems kind of casual without the stupid questions. Yeah, dude. that's why I like it. It's not like an interview. It's literally just Tim and Elon and two of Elon's Starship engineers just talking about stuff. That's cool. Like, dude, that's how I would do it. If that's how Das would do it. If any of us, I mean, Timmy. That's why I like Tim. That's why I like what he does. He's a very, 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 very good content creator. I'll support that guy any way I can. I'm always looking to help. We talk from time to time. Yeah. When our schedules both have an opening, yeah, we talk about that stuff. It's pretty cool. It's pretty cool, dude. But yeah. That's what I like. That's why I like those videos so much. It's not like an interview. It's just Tim and Elon walking around Starbase and talking about everything, which is cool. I can't say that I would do anything different. If I was going to interview him, I'd be asking the same questions. I'd be like, "Hey, what do you like? Why did you do this way? Why did you like? What are you trying to achieve with this? Like, dude?" I'd be firing off questions left and right. Elon would probably be like, "You're talking way too fast." With how much time they had to iterate, I think, like you said, they will try to deploy Starlink 2, a Starlink 2 satellite, or a Starlink 2 satellite or two on the orbital test. Yeah, they definitely are. Those new Starlink satellites are huge, though. They're like 7 meter wide. That's 22 feet wide, and they're going to shoot them out like dinner plates. Like a freaking disc launcher. 7 meter long, 1,250 kilos. Jeez. That's no joke, man. Do we have pics of the new Starlink satellites? No, I haven't seen anything yet, but we've seen the dispenser on Starship, Chris, and it's no joke. Elon talks slow because he processes information in real time. You know what, Ando? Like, you're right. But you know what the thing about Elon is he's a tremendously good listener. He listens to people, and he actually ponders the question. That's what I like. That's one of the reasons I really like that guy. He listens. He listens, and he like, dude, you've ever had a conversation with somebody and they're just yesing you to death? They're like, "Oh yeah, that's really cool. Okay, hey, what about this though?" It's like you're talking to an NPC in Fallout sometimes when, you could tell like if somebody's actually engaged in what you're trying to say. Right? Yeah, it's never a prepared answer. Bingo. Exactly. That's how to be fair, that's how I try to run the stream. I try to listen and try to understand what you guys are saying, like, or what you're asking or whatever. But that's one of the things I like about Elon the most. He's a good listener. He listens. He actually listens and actually ponders what someone has to say. He's actually listening to you. He's actually listening to all the people that ask questions. I really appreciate that. That's really something you don't see a lot. Like every one of Tim's questions. My favorite part of the part 2 interviews with Elon was the first video that Tim released like a week and a half ago, where they're talking about Starship's forward flapping wings, right? And Tim is like, "Well, why don't you just hang it from the wings?" And Elon's sitting there and he ponders it and he says, "No, that's not the problem you want to try to solve, man. No, that's not what we want to do. We want to do this, and this." That is one of the coolest freaking things. That is one of the coolest parts. Dude, they're straight up sparring about like how Starship should be designed. That's cool. That's one of my favorite parts of that entire interview. They're not even interviews. They're just walking around talking about Starship, But yeah, like you could tell that Elon's actually listening. He listens. That's what I try to do, man. I try to be like that. You should listen to people. Like, yeah. you should listen, because honestly, dude, for a long time in my life I would just yes people to death, right? And I still kind of do to an extent. It takes years to undo a habit like that of actually trying to listen and understand what people say. But anytime we listen to a press conference, that's what I'm doing. I'm locked in and I'm trying to listen and I'm trying to absorb as much information as I possibly can, right? And it's to the point where we can answer a good amount of the press questions correctly because I'm listening, right? Half of them. Let's say half. But, dude, you'd be surprised what you pick up on when you do stuff like that. You just sit there, like, shut down everything else, just listen to somebody. You'd be surprised what you pick up. You learn all kinds of stuff. It's really crazy. Did the space shuttle have a lead engineer type figure, or was it mostly designed by committee? Yeah. Hey, Got Nukes, 7-month resub. Keep it up. Thank you. Yeah. Give everyone's idea of the time of day and hear them out. Yeah. I mean, yeah, that's basically it. Yeah, just listening and not waiting to respond. Exactly, Carstaller. There's like waiting to respond, and there's actually listening to somebody. That's something, you know how I always say, like, I never learned how to learn correctly, and I have to do it via repetition? It turns out that if I sit there and I just focus on listening, just listen, just absorb the words as best as you can. I can learn stuff faster that way. And don't get me wrong, that's probably how everyone does it, if I had to guess. But I never learned how to do that right. I just went home and played Counter-Strike, and they're like, "Where's your homework?" I'm like, "Bomb site B." And they're like, "What?" I'm like, "Okay." Long A. It's called active listening. Yeah, no, that's super freaking helpful. You learn all kinds of stuff that you wouldn't be like, "Wow, that's cool." Push B. Yeah. That's one of the reasons why I really admire Elon, dude. That's what he does. He listens. He genuinely is listening to what people have to say, which is really cool. That's a really cool thing, dude. And that's what makes that part of that is what makes these interviews so damn good. Ando, you said it best. He ain't gonna give a prepared answer. He's actually thinking about the question. And dude, that's something that I do. I never try to answer the same question because I get asked the same question all the time. I always try to answer it a different way every time, without exception. I'll never say it the same way twice. I do that on purpose. Yeah, exactly, Endo. Yeah, listening and processing the idea. That's what I mean by listening. You know, absorb the words. Don't just hear them, I guess, if that makes any sense. What are you talking about? Gotta not push B, throw smoke. Yeah, exactly, right? Well, you listen at school when you're not playing video games. Yeah, like I said, Henry, I never learned how to learn right. So, for the longest time I did repetition, but it turns out if you actually just listen, you actually just stop yourself from just going all over the place and just listen, it really, really helps. How did Airplane Simulator go? Went great. I did land on the carrier. I got an A+ landing on the carrier, Don. Yeah, and then I couldn't do it again. I thought I had it, but nah, I didn't have it. And then, yeah, we did a lot of the Maverick challenges. It's just, it looks like it doesn't like the Top Gun music, which is unfortunate. After like 12 attempts, I landed it on my second try. Landed it on my second try, bro. What are you talking about? Oh, listen! Yeah. Anyway, let's jump back over to the Starship news. Let's see what we got. Yeah, man. You got lucky to only have Counter-Strike. Oh. Imagine growing up now and having social media, Netflix, Twitch, dude. LM, two things are gonna happen to kids nowadays. Right? Right? I know! Two things are going to happen to kids nowadays. The first thing is that their minds are going to be scrambled worse than my generation, because our brains are all scrambled all over the place. It's from watching too much TV. It turns out I think our parents were right. I think that whole TV thing didn't rot your brain, but it made your brain want to change the channel every 5 seconds. Now, their brains are either going to be more scrambled than ours are, or they are going to be able to focus on things way better than we ever could. It's going to be one or the other, you know? Can I get you to try War Thunder now that the F-14 is in the game? Nope. No, I'm good. Not too many games. I appreciate it, Laws, but yeah, no, too many games, dude. I think the new generation is actually benefiting from it. They can process information way fast. Yeah, but what depth does it land home, Ando? That's what I mean. Can they just process information? Because, dude, I can read quickly. I can read quickly, like higher words per minute, right? But I don't process the information as well. Can they do it fast and process the information? I don't know. That remains to be seen. People's attention span nowadays is so freaking short. I honestly can't fit in Netflix and games in my busy life. Yeah, Donman, when I was younger, I would bounce back all over the place between different things. It's not just Counter-Strike that I had, dude. I played Counter-Strike. I played Battlefield. I played COD 2. I played Tribes. Tribes was a fun game. What else did I play? I played a lot of Star Wars Galaxies, PlanetSide, World of Warcraft. Those are all really good games, man. Damn. You can process more stuff, but all the distractions are more attractive to the brain. Yeah. I did play Insurgency, Geeson, but not until college. I played Half-Life. Yeah, absolutely, guys. Yeah, dude. Yeah. Never a finer bush-killing simulator. Yeah, right? Yeah, I played all kinds of stuff. Dude, yeah, nowadays, you know what the crazy thing is? Is that nowadays there's so much stuff, right? That I'm just like, there's so much stuff to do that I'm just like, nah, there's so much stuff, I don't have time for any of this. So I just play what I like, you know? It's very strange. You know? In the first episode with Tim, they spoke about ullage gas. It's UULLAGE, alleviate. You're close enough. What is it? Why would they use it? Bonk and honk. I'll tell you in a second. Ullage propellants? Yeah, sure. No, that's oh, wrong monitor. What do you call a pile of cats? A meowton. Oh yeah, not two U's, it's just one, excuse me. Meg has it right. Hi Geeson, how are you? So, ullage gases inside of rocket tanks are... Alright, the short and easy way to say this is that you have to feed propellants into the rocket engines from the rocket tanks at a constant rate, right? Feed it at a constant rate unless the motor throttles, in which case, you know, you go down or up. More or less, it has to feed at a constant rate. I mean, there is throttling, and that does change it, alleviate, right? But, okay, so what happens as you're draining fuel? The tanks are pressurized, right? They're pressurized because you want to prevent boil-off, etc., etc. And they're pressurized for structural stability as well, right? They keep the tanks pressurized so the rocket stays rigid, right? So if you're feeding and draining liquid out of the tanks at a constant rate, but you want to maintain the rocket's structural integrity, what do you do? What do you do? You're going to drain fuel, it's going to drop the pressure, isn't it? Use a header tank? Kind of. Let's take Falcon 9. We'll use Falcon 9 as an example. The liquid oxygen tanks are pressurized for flight. Now you're draining liquid oxygen out of the tank. What do you fill it with? What do you fill it with? Got to keep the pressure up or else the rocket's going to crumple. What do you fill it with? Fill it with gas. That's ullage gases. That's what ullage does. Inside of Falcon 9, there are pressurized helium tanks. They're in what's called composite overwrap pressure vessels, which is basically a scuba tank that's wrapped in carbon fiber. And what that can do is it can store gases at absurdly high pressure. Like ridiculously high pressure. So, when they want to fire the rocket starts draining fuel. The turbopumps are pulling crazy amounts of liquid out of these tanks. The helium tanks vent into the main tanks. They vent into the main tanks to keep the pressure uniform throughout the entire ascent. So as the liquid drains, they fill it up with gas to keep the tank at the right pressure. There are obviously pressure regulators involved, but long story short, alleviate is that the tanks need to stay at the same pressure all the way throughout ascent. And for Falcon 9, they need to stay the same all the way to landing, right? The gases that you put in place of the liquids are ullage. That's your tank. Those are ullage propellants. That's called tank ullage. That's what it's there for. It's there to maintain uniform pressure inside of the tank so you can maintain a steady feed into the motors. Does that make sense? Do they use nitrogen or something? Helium. They'd use helium. Why would you... Someone tell me why helium would be better than nitrogen. Why would you want nitrogen over helium, or why would you want helium over nitrogen? It's lighter. Less mass. Yeah, sure. You got it. That's why they use it. Helium's way lighter. It has way less mass than nitrogen ever could. Now, let's think about Starship for a second while we're on the subject. What do you think Starship uses? Anybody know what Starship would use for its ullage propellants? So, Alleviate, you really want me to blow your mind now, right? Listen to this. So, Starship is using a type of tank ullage called autogenous pressurization. What does that mean? There's no COPVs inside of there. I mean, there is, but they're for other things. I'll tell you more about that later. Long story short, there's a gas tap-off on the Raptor engines. It's before the pre-burners. So you have your liquid methane and your liquid oxygen turbopump. They pump at extremely high pressure, right? And then some of that gets turned to gas, and those pipes are connected into a recirculator system. So inside of the LOX tank, the gaseous oxygen tap-off off of the Raptor engine goes up a pipe back into the tank. And then there's a gaseous methane tap-off. That goes up and that goes into the tank. Raptor makes a tiny little bit of methane gas and oxygen gas off of the side on a tap-off cycle. It's not really called a tap-off cycle, but it's a tap-off, right? It's like the equivalent of bleed air for an airplane, but with rocket propellants. And the Raptors generate a little bit of gas to make the tank ullage gases. True story. It is, Edwards. It's like bleed air. Hey, Fyodor, what's up, man? So, that's called autogenous pressurization. SpaceX is actually not the one that came up with that idea, believe it or not. Anybody know what vehicle used autogenous pressurization before Starship? Hot exhaust gas into the fuel tank. Fuel tank's already cold. Alien, you don't need to worry about it. It's fine. The shuttle. Space shuttle. Yeah, they needed to keep the external tank simple. Why load down the external tank with a bunch of COPVs? That's a waste of time. You're just adding needless complexity to the tank. The space shuttle main engines had a tap-off, and that gaseous helium, gaseous hydrogen and gaseous oxygen repressed the external tanks. Yeah, true story. Look at a picture of an external tank. There's the big main oxygen fuel line that goes that goes down back up into the shuttle, and then there's two little pneumatic lines that go up the side, right next to the huge downcomer on the side of the external tank. They wanted to keep the ET as simple as possible. Why? Because it's expendable, because you got to throw it away. So why add systems onto the external tank when you could add systems on the shuttle that do the same thing and you get the shuttle back? Yeah, autogenous pressurization is not anything new. The space shuttle did it for 30 years. But SpaceX wants to use that. Why? Why would SpaceX want to use something like that? It's not like they're expending Starship. Why would they want to use something like that? Anybody know? This is a pretty interesting train of thought. That's why I'm asking you guys so many questions. Save weight again. Well, that has something to do with it. Somebody said it in chat, Alleviate. There ain't... I'm not going to say that there isn't helium on Mars. We don't know that. I know there's no helium on the... Well, there could be helium on the moon too, but even if there was, you'd have to turn it into gas. There's like H3 or something. But I think that might be hydrogen or whatever. Jensen, hey, tier 265. Thanks, man. So even if there was and we could get it, and you'd have to use ISRU to turn it into gas, then you'd have to repressurize your tanks when you're on the surface. Alleviate, the reason why SpaceX wants autogenous pressurization is for simplification and making it so all you need to do to refuel Starship literally is get methane, liquid methane, and liquid oxygen. That's it. That's it. Simple as that. You don't need any helium. You don't need anything else. No helium, no COPVs, no ullage. Now, with that being said, Super Heavy does have COPVs on the side. And so does Starship, for what it's worth. But in the case of what, I'll get more into that in a second, but in the case of what they're talking about, what Elon's talking about, using ullage propellants as RCS, is basically exactly as the name implies. Why would you have a reaction control system that's a loop reaction control system that's using like nitrogen on Starship? Why would you do that? That makes no sense. The gas is already inside of the tank. And what, you gonna run out of gas from the Raptor engines firing? I don't think so. You want to make more RCS pressure? You just freaking fire the engines for a second, right? The idea, what SpaceX wanted to do was they wanted their RCS to be a hot gas thruster, which uses gaseous methane and gaseous oxygen to make a rocket. And Elon thought that was stupid. Why would you do that? Just vent the ullage propellant. That's your RCS. What does Super Heavy need to do? Super Heavy just needs to basically have RCS to point it in the right direction. Grid fins will do the rest, and then Raptors will handle the catch, right? Why would you add that? That's just needless complication. That's why. Elon is always, with SpaceX and with what Elon does with SpaceX, it's always about reducing it to its base element. Take your idea and boil it down in a crucible and see what's left. It's a really smart way of thinking about things. You can employ that not only if you're engineering aerospace things, you're writing software. That's where that comes from. Any software engineer knows that you have to find the least amount of codes to do the least amount of code lines to do the most amount of work. There are ways to do it. There are ways where the computer works for you, and you can make stuff as simple as possible, and the scripts can actually run faster because the computer doesn't have to read as many lines of code. That's something that comes from software engineering. You have to boil it down. You have to get all of the junk out of your code and make it as lean as possible. That's just, that mentality is being applied to rockets. It's actually pretty smart. Regenerative retropropulsion. Yeah, well, imagine, you reminded me. Alleviate, supersonic retropropulsion is the same thing. You know? Oh, do we need to put a heat shield on Falcon 9? No. What does a heat shield do? It generates a column of gas around the vehicle. Oh, just fire the rocket engine. That does the exact same thing. If the rocket engine's flying backwards, or if the rocket's flying backwards, it does the same thing. And it does do the same thing. It pushes the plasma out of the way. It does the exact same thing that an ablative heat shield can do. Does the exact same thing that an ablative heat shield does. Seriously. It's the same exact idea. One's with this heat shield that burns off from heat flux from plasma, and the other one is a rocket engine that shoots out freaking gas and pushes the plasma out of the way. Same idea. Crazy, right? Yeah. No T-tab either, exactly. And Laser Drifter, that was the next thing that I was going with, where I was going with that. Super Heavy and Starship do have COPVs on them in places. There are COPVs aboard. The composite overwrap pressure vessel bottles that are on Super Heavy and Starship are for nitrogen. They use nitrogen to restart the engines. They basically shoot pressurized nitrogen gas into the turbo pumps on Raptor to get them to start. That's how they restart the engines. Now, why, nitrogen? Why wouldn't you use helium? Why would you use helium? It's lighter. Nitrogen's easier to make, and it's easier to find around the solar system. Way easier. It's certainly a lot less rare than helium is. Helium barely exists on Earth. Helium is in very short supply compared to like hydrogen or nitrogen or oxygen around here. So they basically use pneumatics to restart the Raptors. You want to hear something even crazier? Super Heavy only has enough COPVs to restart the inner 9 engines. The outer, 21 engines or 22 engines, they need the orbital launch pad to start. Well, I know what you're going to say. Well, why? Why would you put the starter motors on the outer engines out there? Well, you don't need those outer engines. They're only first sent. You only need to start them once. The inner engines need to restart because you need to do that whole landing thing. So they only carry enough nitrogen on Super Heavy to restart the inner 9 engines. Also, they're also gimbaled. That's the other part. These engines are the only ones that gimbal on Super Heavy. It's the inner ring. They need that. They need the nitrogen on board to restart the engine so the thing can land. Straight up. This is what I mean about boiling it down. Boiling it down. You don't need nitrogen to restart all the engines. Why? Because if you're flying correctly, you only need 9. Yeah, 13 engines. The outer 12. Yeah, sorry, that's the old picture. It's the inner ring of engines that can be restarted, and the inner ring of engines are the ones that gimbal. Pretty crazy, right? It's cool, man. I love the idea of taking these really complicated concepts and boiling them down, or boiling them off because of propellants. Ha ha ha. Sorry, that was an all-its joke. I apologize for that. You take these concepts and you boil them down to the simplest they can be. That's how we progress. Every time somebody has tried to do that exact thing, we make something crazy, like the space shuttle, like Starship, like Saturn V, like the Boeing 707, or the DC-3 before it. That's what I mean, dude. That's a once-in-a-lifetime thing. That's like once in a generation when you get stuff like that. Are you a rocket scientist in real life or just great passion towards rockets? I'm self-taught. Everything that I know about aerospace engineering is self-taught, Don, man. I literally read stuff like this for fun. This is what I have open on the other monitor. I read this stuff for fun. This is what I do. This is what I spend my days doing. I've been doing this for the better part of 10 years. I love reading about this stuff. It is very strange. I don't know why I like it so much. I can't get enough of it, dude. It's like when you have good food. You ever eat something and it's just so damn delicious, you're not even like focusing on how good it is, you just end up destroying the freaking plate of food and you're just like, oh my god, that was gone. I didn't even enjoy it. It was so good. That's me with rocket science, dude. I don't know what that's about. I couldn't tell you. I could sit here and read this all day. I'm reading about turbopumps over here. This was an article that a viewer linked the other day, or a PDF that a viewer linked the other day. I honestly forget who linked it. This is what I've been reading about hydrogen peroxide turbopumps. Yep, it's just a fluid impeller. He said that just as I stared into an empty bag of chips. Yep. You should be an engineer in real life to understand that, though. Are you one? Nope. No, not an engineer. Nope. Not on paper, at least. No, to be an engineer, you need to have that piece of paper. It's not like a basket weaving degree, you know what I'm saying? I'm a 3D artist by trade, though, if you really want to know, Don. I can manipulate CAD systems and stuff. Did you ever take the girl on a date in summer car? No, I haven't. Fyodor, I've been too busy trying to take actual women's on date. I'm pointing at Remo, by the way. Women's mean not plural. Just don't read into that more. Anyway. That explains where your love of engines and rockets and Kerbal comes from. Yeah, Don, man, I can make engines for KSP. I can make modded parts for KSP. I know all about that. That's what I went to school for. But yeah, no, I really like 3D. 3D is awesome, but I love rocket science. I don't know what the heck that's about. I can't figure it out. I don't know. It's like for the same reason that I like trains. I don't know why I like trains. Trains are, it's just a big rolling piece of metal. Like, who cares? But it's a train, man. It's cool. Right? Trains are cool. Spacecraft are really freaking cool. Like, I don't know what that's about, dude. It's very strange. Yeah, because trains. Like, people ask, why do you like trains so much? Like, you could just say, because they're cool. And it's like, yeah, all right. Yeah, I get it. Yeah, Ernock, exactly. Hey, smart, 17-month resub. Thank you. Don't worry, AJ, I'm weirdly obsessed with railroad merger history. No, that's fine. Dude, yeah, that's fine, Shortline. Maybe you can parry it into a job someday. Like, you know, like, I don't know. I don't even know why I like space so much. It's just, I can't explain it. It's very weird. I just really like it. Spaceflight is like the one thing I can literally talk about every day, and I have been talking about it every day for the last 10 years. There's not a day where I do not mention the Space Shuttle, or Dragon, or Starliner, or Orion, or the Saturn V, the Apollo CSM, LEM. There isn't a day that I don't mention spaceships. I'm literally doing it every day for a decade. Like, I don't know. Dude, it just never gets old. It's very, very strange. You know, like, you know when you get a good game, you buy a new game, and you're really freaking into it, and you want to know everything about that game, and you want to be really good at it? Like, okay, a good example of this is when you first played, when people first played Minecraft. If you haven't played Minecraft, then I'm sure there's another game, but anybody here that played Minecraft, the first time you played Minecraft, you're like, wow, this game is so ridiculous. There's so much stuff you can do. I can do all this crazy things in this game. We can, go get this armor. We can go mine for this. We can do, like, that overload of, like, stimuli, I guess. And then you're just super freaking into it for, like, a couple of weeks or a couple months, and then you're like, all right, I don't need to do this anymore. That stimuli overload that's been happening to me with rockets for 10 years. I cannot get enough of them. I want to know everything about them. I want to know everything. And that's an impossible endeavor. I know that. That's never going to happen. But whatever. I'll just keep telling my brain that that's a possible thing to achieve. It's fine. Yeah, it's just, I want to know everything about it. It's that rush that you get when you play a new video game, but this game is infinitely complicated and it never ends. And honestly, like, when I first started getting into spaceflight stuff, I thought that I would get burned out on it. I thought I'd be like, nah, I don't need to do this anymore. It's like working on my cars, I work on the cars from time to time, and then I'm like, yeah, I don't need to do that for a little while. We're good. Car runs. Just drive it around. Well, not the truck, but you get the idea. And then you get back into it, right? Spaceflight never stops. It never stops with me. I just read about it all the time. Honestly, sad how you don't need to remember crafting recipes anymore. Yeah. I was 10-year-old me in SimCity 2013 for about 2 years. Yeah. It's the forefront of human exploration. It's what we do as humans to be so extreme about the unknown. Yeah, Moto. Yeah, that's cool. But yeah, it just... Spaceflight, I always have that drive to learn more. Always. And I'm not gonna sit here and pretend like the stream doesn't make that worse. Oh, it exacerbates it. It makes it way worse. You know? And then I have to explain it. You got to think about it, dudes. I have to give oral exams on rocket engines every day. Today I gave an oral exam on this stream about nuclear physics. Was I planning on talking about nuclear physics today? No. No. But we had to. So, like, I've been just sharpening that sword for the better part of a decade, man. Hey, Niberius, 28-month resub. It's fun, man. I really enjoy it. It's a really good time. Alright, anyway. Let's keep going. Or the Ferd. The 97 runs. I could daily drive it, Ivo. It's that reliable. We are a bad influence. You're welcome. Yeah. Yep. You know what? Hold on. This VOD's already trashed, so. Tommy Vassetti. Never thought they'd let him out. What are we gonna do, Sonny? We let him loose in Vice City. Yeah, it's a shame, Panther. Oh well. He really was a funny guy. Works great. I don't know, Thomas, but it's working. It's working for me. It's really working for me. That's awesome. Yeah, Ian, they're real nice, dude, huh? Wow. Yeah, right, Ian? Yeah, you can see it right there. That is a big spaceship, man. Holy crap, it's big. That is a freaking chonker. Look at how freaking big it is. Look at it. All right. Pause the music. Pause the music. You know me. I'm never gonna pass up an opportunity to point out scale. All right. You're looking at this picture. You see Starship moving. Now look at the trucks next to it. Holy crap! That thing is freaking huge. Like look at it. That's unbelievable how big it is. I can't believe that. Like, it still blows my mind. You know, I watch this footage every day. Look at that freaking thing. They look like toys. That's right, D. It looks like a freaking toy. Ooh, what's that truck? Oh, neat. Cool. Like, just look at the people walking around. The people walking around next to it. The thing's friggin' gigantic. It's a huge mother. At first I thought the name was lame. That vehicle is deserving of the name Starship. Yeah. I'm with you on that one. Who remembers Micro Machines? Yep. Just, it's a good size. That's just insane how big it is. Left turn. That's just... Yeah, short line, you're right. You have to go see it up close. Well, hang on. Let's see how much counterweight are they running here. 200,000 kilos counterweight. So 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep, 200,000 kilograms. So that's... What is that, 440,000 pounds of counterweight? Basically 500,000. Round up a little ways. 500,000 pounds? Something like that. Yeah, that's a lot of counterweight. You know, a lot of people are asking one hop, guys. I think this is going to happen a lot sooner than we think, dude. I think the FAA is going to let it go. They're gonna release the PEA, and I think it's gonna pass. I wish they hadn't already used the Dragon name, because those tiles look like scales. Dragon ship would be cool. Maybe they'll name one Dragon. Yep. You gotta put the metal plates down. Bam! Bam, 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 bam. Bam, bam, bam. Bum, 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 ba 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 bum. 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 Ba 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 bum. Ba 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 bum. Look at that thing. Can we get Vice City back? Sure. Yeah, Red Munchkin about there. Yeah, that's the counterweight. Not including Starship. I agree, .com. These tiles look way better than 20 and 22. They also fell off like 20s and 22s, though. It's pretty cool, Don, huh? This is cilia. It's a cilia back. The cilia back tiles right there. That's what that white felt looking thing is with the netting on it. At least that's what I think it is. I don't know for sure. How thick are the tiles? They're varying thickness unit. They're thicker in the parts of the vehicle that are going to get hotter during re-entry. Hotter. Are they as fragile as shuttle tiles? Nah, they're a little bit stronger, fellas. Yeah. Hodor. Look it has the Starlink dispenser on it, guys. Payload bay. Mordor. Nice. The music cutting with the camera is pretty good, man. Enroy looks kind of sus. Don't do that again. What are they held on with? Super glue? They're glued in some parts. The tiles that are glued have the like white lines in between them. These tiles that are on the body of Starship, those are bolted. They're bolted on. I don't know what those 6 tiles are for up there, fellas. Dun 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 dun. So this is like the USA's Karelian Corvette. This has a little less engines than that. Yeah, I don't know what those are for. I couldn't tell you. So the bolts failed, or the tiles crumbled around the bolts? I don't know. Origin? Yeah, I don't know. I'm not sure what happened. Here. Well, while we're here. So this picture was Starship Gazer. Take a look. Yeah. Some of them popped off. I'm curious as to why they popped off right there and only in that location. I'm not. The nose cone and everything seems just fine. The main structure seems just fine. Right here is the top of the methane tank right there. First of all, why is this thing? Why are we popping off tiles in spots where there's no pressurized tanks? Like, and why that particular spot? I don't know. Is that a big issue? I mean, you don't want to lose the tiles. Was this after a cryofill? Yep. Yep, they moved it to the pad yesterday and started tanking this thing, fellas. Yeah. They put it there for tank testing. Night Sun Temple. Yeah, I'm not sure. A bang was heard and then tiles flew. Uh-oh. Workers just removed a very bent section of pipe from 24, perhaps related to the bang noise and tiles falling off during cryo testing. Oh. Oh, I hope that wasn't like that when they tested it. Uh-oh. That pipe is very kinked. Yeah, that's no good. Yeah, something may have popped inside of it, dude. Styles were put on a Friday. I'm not sure people will understand that reference, Origin, but I do. You don't want to get the car that's built on Friday. Yeah, Origin, I'd have to say that's kind of looks like what happened, yeah. Or a Monday, yeah. You want a car that's built on a Tuesday or a Wednesday or something. It's very interesting that on the major structural bulkheads, so like that's the bottom of the methane tank, that's the top of the methane tank, that's where the nose cone transition is. They didn't fill it all up with tiles. It's very interesting. I can't unsee that now, Enroy. Damn it. I can't unsee it, man. The payload bay is pressurized, so is the payload bay pressurized? Ian? Why would it be? It's got a freaking hole in it. The bit you mentioned was the bottom of this from the bottom of the CH4 tank. It actually is the center of the tank. They did a different stacking procedure. Interesting. Yeah, Belon confirmed it. Not sure how that'll work. I mean, Ian, yeah, you kind of have to for structure. That's a camera right there in case anybody's wondering. I still don't know what those things are for. I think those are antennas or something. I don't know for sure, though. Hey, Big Show. That's the Starlink dispenser. Antennas, they're also on the other side. Yep, yep. Heavy. Heavy, 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 heavy. Was ist? TIE fighter? Ah, yes, the super laser. Yeah, okay. The payload bay would need to be pressurized in order to maintain structural rigidity. I think so. Death Star. Yep. Yep, makes sense. They're hooking up the umbilical to it. More liquid oxygen is showing up at the orbital pad. I would have to say that I'm pretty sure that SpaceX is gearing up for A, at the very least, some static fires, and B, possibly an orbital flight test. What is that? Okay. Cap for a fin cover. Okay. Still pouring more concrete around the suborbital pad. Radioactive armadillo. Bird. Steamroller. Bulldozer. Oh, front end loader. Dirt bike. Bird. Spidmit. They need to work on their drainage. Told you this road got wrecked. All the infrastructure is nowhere near designed for this amount of traffic, but they're getting there. Temporary building. Yeah. How many axles does that thing have? The SPMT? Oh, yeah. It's basically just a motorized pallet. Ah, yes. Building. Oh, look at that F-450. That's cool. He's a nice truck. Oh, these were the segments that were on top of the, this was on top of the power station. This is that's the power distribution house for the pad. It's the same temporary building. Yeah, hard pass. That would be my guess, Ian. Is it necessary to have air conditioning for each segment? It depends. Dan, if I had to guess, that air conditioner is enough to cool the volume of those prefabricated segments, so you move the window AC unit with the prefabricated segment. If you have more of a prefabricated segment, you can condition successfully that amount of volume. Remember, air conditioners, yeah, it really depends on the volume. The volume of the room that you're trying to cool denotes the size of the AC. Now, I know you guys don't have AC over there. You guys don't do that. You lot just complain when it gets hot. Oh, it's too hot. It's too hot, mate. It's too hot. And then in the winter, if it snows, oh, it's too cold, mate. No, but Father, it's too cold outside. And then it's cold and rainy and yucky, and it's like, no, this is just fine. This is just fine. We have AC in our cars, but we never get them charged once they run out. It's too hot, mate. It's too cold. Crappy rainy weather. Yeah, this'll do. This was joke. This is the propellant production plant. Haven't seen much action from this place in a little while. Wonder what they're up to. Nah, that's pretty accurate. Yeah, it's a methane transfer tube. Who needs aircon? You can buy a brand new pedestal fan every year because you forgot how hot the summer can be. Dan, that just seems like a very British solution to the problem. It's a very British solution to the problem. I just buy another fan, mate. You bought one last time. To be fair, I have a fan going right now too. I mean, we don't. Over here in New England, we don't. Not every building comes with air conditioning because they're all old. Yeah, that sound familiar, fellas? New England will have air conditioning as standard. Yeah, probably. Ah, Raptor. Actually, Dan, that's NU, England. New, like new metal. Your words, not mine, man. Anyways, you got AC last week, got sick of the heat. So worth it, man. I firmly believe, dude, my air conditioner, the window unit, I run that window unit almost all the time, year round, because the computers generate so much heat. And I don't put the computers through as many thermal cycles, right? Because it stays cool in here. We can keep the cold air coming with the air conditioner, right? Dude, even in the winter, I know that sounds dumb, right? Even in the winter, it takes all the humidity out of the atmosphere and it keeps it at a uniform temperature. That's part of the reason why the hardware has lasted so long. Guys, my streaming rig is over a decade old. Easily. I bought it in November of 2011. It's over a decade old. Still works. Still works great. And I'm not talking like, oh, I use it every once in a while. I use this computer every day. Every day. It does encoding for 12 hours every day, and it's taking it like a champ. Literally no problems. Where you eat corn and still have cold. There you go, Dan. Yep. That air conditioner has paid for itself many times over in my hardware not completely taking a dump. Speaking of hardware, oh my God, look at that thing. Get the crane out of the way. No, come back. I prefer Thrash England. Speed England. Thank you very much. Okay. Speed England. I'll take my Deep Purple. Thank you very much. Still I need is burn. It's a great song. Sounds like your streaming rig is mission critical. Got a backup system? Yeah, of course. I may or may not have used my stimulus check to buy a laptop that's good enough to be a streaming rig. Yeah, it's good enough to stream from. That stimulus, though, I really needed that. I used my Trump bucks. What? That's what they called them or something. I don't even know. I used the stimulus during COVID to buy a really nice laptop. So yes, I do have a backup just in case. The Donald dollars. the Donald dollars. I'm a waster. Oh, Dan, if I get if we score the house that I'm trying to score right now, the garage should be big enough to put the drum set back up. The real drum set. I'm talking the Ludwig Maple kit with Remo heads, Zildjian ZBT cymbals, and DW hardware, with an Iron Cobra 5000 double bass pedal. That's what I'm talking about.
Discovery.
No, not Remo heads. Remos. Remo heads would be very strange. Asmalok, gifted a sub to Netlag. That's a tier 1 sub. Thanks, man. Yeah. We are... That's what it was for. Yeah, that's what it was for. And then during that whole pandemic, oh man, everybody had to work remote and work from home. That must have been hard to adjust to for some. Yeah, Origin, that's the idea. I'm gonna have to take a long trip to your garage for a jam out. Yes. Yes. Yeah. Yeah, man. It's pretty good. Pretty good. Soon. All right. I think we got everything. See if I can get my bass in an overhead bin. Yup. I'll play the triangle. Ding, 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 ding. No, don't worry about the triangle. Screw triangles. All you need to do is play the 3D triangle. There you go. See? 3D triangle. Guess what? I got a fever, and the only prescription is more cowbell. Guess what? Gotta have more cowbell, baby. It's still funny. That's still funny. I used to play the triangle in a reggae band. I just stand at the back and ting. Okay. Shall we? All right, I think I got everything for space news there. Got a fever. The only prescription. Small cowbell. Let me just double check. Let me go through the links again. We're doing racing during stream again? This is Friday night racing, dudes. Friday night racing is in Assetto. It's not GTA, and it's on a closed server with a password and everything. And yeah, because of that, it's almost like you're less likely to get hackers if you have a dedicated server. All right. Yep. All right. I'm just looking through to see if there's anything else here. I think we got most of it. I think we're good. Don't know if you've seen this. Is that the tiles? Starship gaze? Is this the Starship? Yeah, the bent pipe. We just looked at that a second ago. Interesting. It's about SN24? Oh, don't apologize, Liam. We're good. All good. Did you watch Tim's video? Few neat shots up the tower. I did, Enroy. Yeah, I did see it. It's just... that thing is... Starship's nuts, dude. It's just nuts. It's just nuts. Like... Alright. The more and more that thing comes to fruition, it's just... it's just absolutely insane. Is it just me, or do you guys also get the feeling this was the first time Elon was on the tower? Yeah, maybe. Maybe it was. Hang on. Give me 1 second. Got a message. Was the FCC meant to be today? The FCC license starts today, and Foz, that was my indicator that the PEA is going to happen. The FAA is pretty much there. I think they're good to go. They finished what they were working on. So that cruise ship that caused SpaceX to scrub in January hit part of a dock today. Oops. Just got to look into something here before we start racing. The dude is building an empire. It's nuts, man. It's absolutely insane. This noise is probably not going to be I'll take things you don't want to hear on a ship for 500. I love how the people are like, who's driving the dang boat? That's funny, man. Opinion on the clickbaiters, game over, SpaceX invents new fuel. Do you really want to know, Sanchai? Okay. I know good and well that YouTube is not an easy grind. But we looked at those game over, Elon farts new rocket propellant videos. Dude, literally each one of those videos has like 4 million views. That channel is super successful. And we looked at it the other day, Sanchai, and dude, I know not to think this way. You know, and spaceflight has taught me not to think like this. Not to think that, you know, wow, that's dumb, I can do it better. But also at the same time, those videos are full of nonsense. What happens if, like, we did a YouTube channel like that, but with, like, the actual, like, not clickbait stuff? Like, I'm not talking about space news, kind of a more syndicated thing than that. Like that, but not clickbait. I think they get a lot of traction with non-native English speakers and people who aren't familiar with space. Yeah, Ian, what's stopping us from doing that with actual spaceflight information? Honest question. Like, is there like, how much traction do the NSF vids get? How many? You know, let me look. Let me see. Well, isn't that what Scott Manley, Tim Dodd, and NSF are doing? None of them are getting anywhere near the clickbait channels. Yeah. Is this even the channel? Hold on. Look at that thumbnail. That thumbnail is awesome. What the hell? Dude, that's terrible. That's terrible. Yeah, that's... Oh my god. That's what I'm talking about. There have been certain YouTubers out there that use clickbait titles that weren't actually clickbait to great success. If I'm remembering that right. There's this guy that's actually pretty cool. He's a chef or something. This guy. See, you remember that guy? Yeah. Ian, what if we did that though? What if we did that though with just actual spaceflight stuff? Like, all right, how much do the NSF videos get? Let me see. Let me take a look. I've never actually looked. I just showed people the videos and hopefully they see it. Let me see. What do we got? 48. 108, 41, 60, 68, 46, 93. Is it actual views? Oh, I'm not sure. I think he does burgers or something. He's a chef or whatever. Hmm. 75, 67, 44, 57, 96, 60, 74, 91. Huh. 399 there. Why Falcon 9 is better than SpaceX ever thought. That's a good video. Look at that one. That one's got 400,000 on it, Ian. That's not bad at all. Give me 1 second. $100K over here. Here, hold on. Let's go back over here. Oh yeah. Wow, look at the Starship tests. Wow. Yeah, the Starship tests. Crazy, dude. Hey, Vulcan, you're at Indy. Cool. Yeah, the algorithm took that Falcon 9 video and ran with it. Yeah. Sort by most viewed. Yeah, I got you. What's, Ian, I'm interested, like, and I don't mean to go peeping on NSF. I'm like, I could probably just go ask Das this question. I'm trying to see what's the highest video that's not like a live stream or a cut live stream. There's inspiration 4. Starship Stakeout. The recovery videos, huh? Yeah, those Falcon ones, man. The ones that are talking about how Falcon 9 is recovered and stuff. SN9. Ugh. SLS Green Run 432. Interesting. There's the underestimate Falcon 9. Those two videos are the ones that have done the best. Ian, I'm talking about making videos like that. Like, you know the Saturn V infrastructure deep dives that we did during a couple of Space Newses where we figure out, like, all the different serialized versions of Saturn V and where they are, etc., etc.? I'm thinking about stuff like that, dude. Take a look at Tim's videos. Alright, what's Timmy doing? Tim only has 1.2 million subs. That's it? Oh, dude, no. That's got to change. That should be like triple that. Like, I don't mean to go peeping on Tim. I should probably just go ask. Dude, look at this. Ian, we gotta come up with some copy and get videos like this for NSF. I wonder, maybe I should ask Das about that, dude. Dude, look at see what I mean? Look at how good Tim is. He's nasty good. He's nasty good at what he does. Tim has an entire team, so does NSF, dude. Soviet rocket video did 1.6. What's his most viewed one? Oh, the interviews with Elon. Dude, it has 5.7 million views. Raptor engine has 4.7. Damn. Dude, I can write copy that's good enough. Like, dude, we can write copy. We can make this happen. We should do NSF. We should do NSF educational videos. In fact, you know what, Ian? I'll be honest with you. I'm fairly confident that there's no way that this hasn't been thought of. There's no way somebody like Chris or Chris or anyone else hasn't thought of this. Yeah, Senshai, of course. They have it. Brilliant. Yeah, that's a good point. Systems engineering, Smirks? Yeah, we could. Dude, we could. See, that's what I mean, dude. Like, Ian, I look at that clickbait crap, right, on YouTube, and I think, like, dude, why can't there be okay, I know this is a stretch. I'm not saying that this is like where I would want to go, like where it could end up, but like why isn't there like a Mr. Beast like space YouTube channel? You know what I mean? Like, that's how Mr. Beast got his start. He got his start by making clickbait titles that were actually true. That's what he did. That was smart. That was really smart. You know what? Why can't we do stuff like that, you know? I would kill to be able to make a video on the Saturn rockets, to be honest. See, yeah, Sanchai, you asked what I was thinking about, you know, those clickbait channels, and I'll be honest with you. What I'm thinking is that I can do better. I can do better and convey actual information. As far as I'm concerned, that's uncapitalized markets for spaceflight education that are A, being taught wrong information, and B, it's there. I mean, do you see those numbers on those damn videos? Even Tim's videos. Easily, all of his vids are easily over 1 million views. Easily. Show us your YouTube thumbnail face. Actually, it's this. EJ Pog face. How would a Mr. B space vid be? There it is. Yikes. Game over. SpaceX cancels Starlink program. There's got to be a way to do this, Ian. The market on YouTube is just so gigantic. And don't get me wrong. I'm not saying like I'd go to YouTube and I'd never do Twitch. That's not what I'm saying. I'm saying do both of those things. Because if you find a way to do both of those things, right? You find a way to do both. You feed one into the other. You know, if you stream and then you YouTube and then you stream and then you YouTube, you're blanketing everything. You can bring a lot of YouTube YouTube viewers over to Twitch. And YouTube has a way bigger market. That's what I'm trying to. That's what I'm trying to get at. Like you could make the stream way bigger, like way bigger, with the right engagement, dude. I know, Homie Pigeon, I know Marcus House. Yeah, and I know him. Yeah, I'm talking about stuff like that, but we gotta find a way to hype it, but not hype it up. They probably need another channel for educational videos. It's hard to find stuff within their daily Starbase updates. Yeah, Obtruse, yeah, interesting. I don't know, Sanchai, like, you know, you're saying, like, what would like a video like that be? I don't know. Starlink launch. gone wrong. Gone orbital. Damn, gone orbital. Okay. Falcon 9 launch. Landing. Gone orbital. Probably do that. I'm dead serious. I'd probably do that. Needs a lot of editing time. Takes and retakes. I'm used to doing things in one take. That's fine. A lot of streamers just haven't edited a tape, honestly. Yeah, I know. Yeah. I mean, I can tailor explanations. That's no problem. I can tell you everything about Saturn V right now. I have that information queued. You know. Dan, you took your mother to her first concert on Wednesday, which was Alice Cooper with the Cult opening. That's awesome, man. What you think? There. Are you happy now? Yeah, exactly. Yeah, there you go, Sanchai. Yeah. Retakes aren't bad. I can crank out a 10-minute voiceover in 1 to 2 hours, including retakes. Yeah, yeah. She's been a fan of Alice Cooper since the 70s. She's loved it. Yeah, fellas, it's doable, man. It's totally doable. And then I can do car stuff too. Like, that would be pretty sick. We probably need another YouTube channel for that. If you want to cringe at more cancerous thumbnails, then click here. For frick's sake, man. Wait, that's the same thumbnail as another... Whatever. Just happened, just happened, just happened, just happened, just happened, just happened. Yeah, we got to be able to, like, have accurate clickbait titles. You know? I don't know. That's what I think, Sancha. I think I can do better. If YouTube videos had my full focus, I would yeah, we can do better than that. I know we can do better than that. I know, I just know we can do better, you know? Like, we can anyway, whatever. I'm rambling now. So, I'm going to get into doing some racing now. I got to do some practicing tonight. We got two big races tonight for the EJ Eric Johnson Racing Administration Cup Series here. We have the LMP Series and then NASCAR as well. So, it should be fun. Let's get Assetto up and running and go from there. So do it. My plans are to really start looking into it after the whole house thing. And Spaceman, in terms of house news, no news right now. But no news is good news because the bank's doing an appraisal. If I don't get a phone call right now, that means everything is going right. So let's start a Friday night racing and we'll go from there. Indy 250 and Charlotte 300. Ugh.
Discovery, go at throttle up.
Beautiful stream and streamer. Love it. See ya. 30 months from 95.